Good morning to everyone from India, and good evening to everyone from US who has joined in the class. This is Abhishek here, and I'll be I'll be your training guide today. I'll be able to I'll try to help you out with the presentation today. And today's the presenter today is Nidhi. Okay, she let me just introduce you to Nidhi. She has around almost like a decade of experience in the industry. For past 2.5 years, she's been working on big data analytics. So she's an expert in this domain. If I'm audible to everyone, I mean, if I'm not audible to anyone, please write it in the chat window. If I'm audible to everyone, you can quickly write that also in the chat window. Yeah. Can everyone please quickly write it on the chat window if I'm audible? Okay, great. Hi Shrikant, how are you doing? So great. So everyone, if you can just quickly write it on the chat window that if I'm audible to everyone, great. Yeah, so I've got some responses, and for people who are not able to hear me, I'm sure they'll just complain in a while because they're not able to hear me. They'll not write. Okay. So looks like everyone, I'm audible to everyone. Great. So yeah, I think we will also get started. Before I hand it over to Nidhi, what we're going to do is we're going to quickly have a quick round of introduction with everyone here. Okay. So I think some people have introduced themselves. I'll just read it down, and I may not be able to introduce everyone. We'll just save some time. We'll keep on introducing you. It's a long course, so we'll get to know each other very well. And there's a discussion forum also which will be there on your learning management system. There also we can start a thread there. Okay, so I have Gaurav who says, Gaurav, hi, my name is Gaurav. I'm from Bangalore. Currently associated with IBM GPS, working for client and market analytics team. Welcome, Gaurav. Welcome to the class. Then we have Dipankar. Dipankar says, this is Dipankar joining from Phoenix. Hi, Dipankar. It looks like it will be pretty late there, but yeah, great. Great to have you in the class. I have 8 years of experience in mainframe background trying to learn something new. I'm sure you'll learn a lot here. And okay, then we have Ranjit. Ranjit says, hi, I'm Ranjit. I'm from Bangalore, currently working with IBM as business analyst. Welcome, Ranjit. There's Vinay from Maharashtra. Then there's Parthiban joining from Sydney. So great. So having 9 years of experience in mainframes. So we have a pretty much global audience today. Great to have you guys. Then we have Dilip. Dilip is looking for, he's trying to get certified. Great, Dilip. Tushar is saying I'm not able to connect. So what we'll do is someone from the support team kindly get in touch with Tushar and check what's the problem with him. Okay, Avinash has around 8 years of experience in the industry. Okay. Balwinder says, please speak a little louder. So anyone else facing this problem of not able to hear me clearly, please write it on the chat window. Okay, so Balwinder, is it better now? Tushar is from Bhubaneswar. We have Suman and Shrikant. Shrikant has joined from California. He has 7 years of experience in Java and J2E. Suman is Vamsi from Silicon Valley, working with Cisco, 15 years of experience. Great to have you, Vamsi. I'm really happy with. We almost have a full house. We have almost like how much 15 odd people in the class. So we have Vinod as well, and then we have Vardhara Raju. What we'll do is I'll probably not introduce everyone now because we'll get started. I'll just introduce you to your presenter today. She, as I told you initially as well, her name is Nidhi, and she has around a decade of experience in the IT industry, almost like 10 years. Past 2.5 years, she's been working on big data analytics. So she is also one of the early people in India who have been working on big data. So I'm sure you'll have a great session with her. I'll probably hand it over to Nidhi now, and I'll be there to answer any questions. I'll remain connected to the class. Okay, Nidhi. So can you? Let me just check if. Nidhi, can you just quickly speak something? I just want to make sure that you are audible to everyone.
Yeah, sure, Abhishek.
Okay, great. So guys, if you are able to hear to Nidhi, can you quickly write it on the chat window, and we'll get started without wasting any time.
Okay, Abhishek. So it seems I'm audible. Getting a lot of yes from audience.
Great. Okay, guys. Okay. So now one more thing. I just wanted to tell you everyone that by default everyone is on mute. Okay, and we keep it that way because to avoid some background noises, right? I mean, you may be having kids at home, so we don't want everyone to hear them. Okay, but then I mean, if you have any questions, please write it on the chat window. If there is anything which was not answered in this class, it was missed in the chat window because a lot of questions keep coming in. Do not worry. The support team looks at each and every question, and after the class they'll respond back to you. Is that okay with everyone? I mean, that will be the modus operandi of the class. Okay. So okay, great. So I'm getting a lot of yeses, and please make sure that you remain interactive with Nidhi. She should, I mean, she will keep on asking you if you're with her. So please keep responding in the chat window so that she knows that everyone is following her. Any questions? It's not only this class. There is a support team available. You can ask them questions after the class. Then, I mean, we will be having a lot of other things in the after this class. So just to introduce you how this course works. Other than these classes, we'll be doing some assignments. Okay, these will be practical assignments. All of you would have set up the cluster on your machine. If not, the support team is going to help you out with that. And then there will be after every class there will be these assignments. And then towards the end of the course, we'll be doing a small project. Okay. And then we'll have a 2-hour exam at the very end, based on which we will be giving you a certification. Okay, so now I think that's it from my side for now. I'll keep myself on mute and hand it over to Nidhi. Okay, Nidhi, thank you very much, guys, and get started. I hope you have a wonderful experience today.
Yeah, thank you, Abhishek, for doing the round of introduction. And we'll quickly get started because we have just 3 hours and we have a lot to cover. So we'll just start. I'll keep it interactive as interactive as I can, so that it doesn't get boring. And I also know that who all are following. And then we can take up questions also in between sessions. But as Abhishek mentioned, that we might not be able to answer all the questions within the session itself. We'll try to answer most of it. If anything is missed out, you can always reach out to the support team, and all your questions will get answered. So Abhishek has already told about how this course works, and he has said the modus operandi. So we'll just start with the presentation today. So guys, as you all know, this is an 8 weeks course. You should have seen it when you registered for the course. Week 1, that is today, we'll be starting with Introduction to HDFS. HDFS stands for Hadoop Distributed File System. Might sound like a jibber jabber right now, but at the end of the session, you will be able to understand very clearly what it is, where it stands, and how we can leverage it for analytics. In week 2, we'll be learning about setting up Hadoop cluster. We'll be doing some hands-on. We'll be showing you what happens inside a cluster, and you can do it yourself also. We'll support you in that. In week 3, we'll be talking about MapReduce basics, types, and formats. This is actually the programming model that Hadoop incorporates. And a little pointer here, to work on MapReduce, you will need to know basics of Java. In any case, we have some people who are from Oracle PLSQL background. So in case you are not familiar with how Java works, a very basic information, in case if you are not aware of it or not worked on it, you can take up a free Java course that comes along with the course. So that will assist you, help you better in understanding MapReduce basics. In week 4 and 5, we'll be talking about the tools that can be used to work on HDFS, that is Pig and Hive. We'll also look at a data stored HBase, and we'll talk about Zookeeper and Scoop towards the end of this entire course. So that's about the course topics that we'll be discussing. For week 1, that is today, I'll actually talk about, this is an introductory class. I'll set the stage for Hadoop. I'll walk you through the internal architectures and how read and write happen. And please don't expect demos today, because this is an introductory class. We'll have demos, a lot of demos in fact, in the next 2 weeks. And in case you're not able to work on those demos, we always have our support team to help you with all those demos. Yes, Dipankar, I'll send you the details of the class. She's asking if we can join the Java classes. I'll send you those details. So we'll get started. Firstly, we just have what is big data, because Hadoop, the endpoint today is to understand HDFS. That is a part of Hadoop ecosystem and very integral part. But to set the stage for Hadoop, we first need to understand why do we need Hadoop at all. So that is because we have lot of data, and this lot of data is actually termed as big data. Now the slide that you are currently seeing on your screen has 4 pictures, which these 4 pictures, when you look at it from the first shot, they do not seem connected at all. Do they seem connected to anyone? Can I have any guesses on the chat window how these 4 pictures are connected? Lot of data, yeah, correct, Ramsey. This is a lot of data. It is big data. So I'll take up each of the picture one by one. We'll discuss on the use case, and correct, Gaurav. They have a lot of data. We'll take up each one of them, and by the end of the session, we'll come back to the same slide and understand how Hadoop helps us in these use cases. So first one is Facebook, a very familiar friend for all of us. We all have accounts. We do a lot of activity. We post our stuff. We like images. We like a lot of things, status. We do chats on Facebook. So all these things actually generate a lot of data. And all this data has to be dumped somewhere so that Facebook can do some analysis on it to know how their business is doing. So this image is actually a bit old. It just says 500 plus terabytes of data per day. As of today, according to recent stats, Facebook generates petabytes of data per day, which actually is huge data for every day. If you see petabytes of data over a span of time, it would be okay. But for every day, it is actually huge data. So Facebook needs to store this data and then analyze it. In the next picture, you see an aircraft in flight mode. So how can that generate data? Can you think of any, can I have any guesses here? What kind of data this aircraft may be generating? Okay, so we have a few answers, out of which I also have correct answers. So we have traveling information, says Ranjit from Vamsi. I have the correct answer, that is black box data. Avinash also, this is correct answer. Other options are booking, schedules, different type formats of data, and growing data, says Baljinder Singh. Yes, so the correct answer is black box. A lot of data, booking and black box. Delete, black box is the correct answer. Booking it does not contribute to big data. I'll tell you why it does not. Okay, we will discuss on the black box. I assume everyone knows what black box is. Since we've already have so many answers on black box, I go with the assumption that everyone knows about it. Let's just think of an unfortunate, black box has big data, correct? So black box let's just think of an unfortunate situation wherein aircraft meets an accident, and there is no other mode of no other source of information as to what happened, what led to that accident. In that scenario, we can use this information which aircraft generates. And to tell you, it might be a bit surprising for many of you. An aircraft in flight mode, for every 30 minutes of flight, it generates 10 terabytes of data. So that actually is huge data. If you think of a flight that is in flight mode for 3 hours, think of the data that will be generating. So that is the amount of data that we have coming in from aircraft, and we need to store this data and then analyze this huge amount of data to know what happened if a flight met an accident. Not only we can analyze what was the cause of accident, we can also, if we monitor it on a regular basis, we can also know if an engine starts behaving abnormally, then airline can go ahead and do something about that problem and resolve the issue to save an accident. So that's about the second picture. Moving on clockwise to the third one, we have a power grid system there. So any guesses on what kind of data this power grid system would generate? Okay, I'm getting no answers. Black box was very quick. Okay. So I have answers from Ambarish, Ramesh, and Vansi. Again, electricity transmission, customer info per second. Yes, correct. It is electricity transmission per second to multiple nodes. Today we see we are surrounded by electrical gadgets all around us. It's the world of wires all around we have. Yes, Suman, I'll come to your point just in a while. That's a very good point you've raised. I'll come back to it. Let me just finish the 4 use cases and then I'll come back to you. Okay, so this third picture talks about electricity transmission. So easy to understand, we have a lot of electrical nodes and data being transmitted between them. Definitely will generate a lot of data. And then again, we need to know what is the consumption so that we can know which are the areas where consumption is most, where consumption is minimum, which peak times to cope up with the peak times, all those things. Big data can help us in that. In the last picture, NYSE needs no guesses. It very clearly says it is NYSE. And every second of data changes in NYSE actually changes a lot of habits of a lot of people. Do we have stock investors here? Anyone? I am sure we have so many senior people. Yes. So I have a lot of people saying yes. Correct. Yes, it is trading data. Yeah, right. It is trading data. Okay. So I have a very interesting question from Suman. He says that can we tell that big data existed way long back? Now this is a very interesting question. Yes, Suman, it did exist way long back. It has always been there. The only thing is that earlier we didn't have the resources to or we didn't have the proper technique to analyze this big data, because that was the era when we were using RDBMS systems. All the people who are currently using RDBMS systems, please don't take it against me. Just I'm talking about the new thing that we are studying today. So when Hadoop came in, people always knew that big data can be of or it is of huge value. We can derive a lot of value from it. But earlier we just didn't know how to derive that value. When Hadoop came in, or when Google came in with this concept, we got answers to the question how to derive values from this data. Yes, correct, Vamsi. He says, I think all our life we have big data, newspapers, textbooks, government files, etc. Everything is big data. Yeah, adding to it, our memory is also big data. We have so many things stored in, although it keeps coming in and going out, but still there is big data. Okay, when did Hadoop come into market? It came a few years back, Ramesh. This project started way back, but then it has been very popular since the last 3 to 4 years. Yeah, Vamsi says we cannot program our mind. Very much correct. Had we been able to do that, world would have been a different place. Okay, so okay, so that is about big data. It existed before, but we didn't have the technology to analyze it, to work on it. But when big data, when Hadoop came up, we got answers to those questions. On this slide, I'll quickly tell you the formal definition of big data that goes around. It is easier to remember also, and it makes sense to categorize data as big data. So let me just talk about the first 2 images that we talked, Facebook and the aircraft. I have a question from Ramesh asking earlier day how they were analyzing the big data. Ramesh, not all the data was analyzed, only particular sets of data were analyzed, and most of the data was discarded because we didn't have the resources. I am not sure how many of you have heard of the Hadron Collider. That is one of a very sophisticated scientific instrument used by physicists and highly revered, I would say, by physicists. It is an equipment that generates around petabytes of data every quantum of hour or every quantum of hour. Okay, I have a question. What cannot be the use case? I'll come to that. What cannot be the use case? I'll come to that. What happened was, before big data technologies came in, most of the data from Hadron Collider was discarded because there was no way to analyze it. But since the advent of big data, people or scientists have started using more information and deriving more value out of it. Okay, so talking of Facebook and aircraft, we have data being generated by these 2 sources. Okay, I'm just limiting these two sources for this discussion. There are definitely several other cases. So we have a lot of data coming in from these 2 sources, and this data cannot be focused or cannot be marked as rows and column format. All this data is in the form of log files. All this data comes in the form of log files, and we call it as unstructured data because we do not have rows and columns in it. We cannot feed it into our relational RDBMS system. Can you feed in a log file into a relational RDBMS system in the form of a table? No, definitely that is not possible. Okay, I have notes coming in. That is good. So so we all understand that data generated by these sources cannot be fed into a relational databases systems, and we need something else to process this data, right? So we'll say that this is the variety of data that is unstructured. Now your audio files, video files, logs, server logs, Unix logs, Windows logs, everything falls under unstructured data, and all these unstructured data is also quite different from each other. You'll have a different format for Unix logs, you'll have a different format for web logs, and then audio and video files will be entirely different. So that is the variety of data that we have when we talk about big data. Then we also saw that this data comes in at a very huge rate. Like in Facebook, we get petabytes of data every day, right? So that is the velocity of data that comes in every day, and then we have the volume of data, like petabytes of data coming in every day. So that is the volume, and velocity is at what frequency it comes. Okay. Now what do we do with these three V's? We have volume, we have variety, and we have velocity. So what do we do with that? We combine these three to derive the fourth V out of it. What is this fourth V? This is value. Okay. So we store this data, analyze this data, and find some value out of it. So in most of the big data technologies that we set up, we always talk about finding needle in a haystack. So it's like that. You have a huge amount of data, but the business analytics that will come out of it will not be proportional to the big data. Okay. So we say finding a needle in a haystack. So now what is big data? We have three V's here. It's V4, says Dilip Gupta. Yes, it's a V4. How we put it as, we have three V's and we use it to derive a fourth V. Suman says, can you please be a bit slower? Guys, is it difficult to understand my pace? I'll definitely bring it down. Okay. Okay. Okay, so I'll make it a bit slow. Yes, Siddharth, we are still on the first slide. It is because it is very important to understand what we are dealing with. So we'll spend some time here so that we understand what we are dealing with, and it becomes easier going forward. Okay, Rajat says that I am a bit. He says he's asking me to come closer to the speaker. Microphone volume is low. Is everyone facing that issue? Hearing me? Am I not very clear? Okay. Okay, so it is clear for some people, not clear for others. Sometimes volume is low. Okay, I'll take care of that, guys. No problem. And Avinash has summed it up for us. He says value equals to velocity plus speed plus data. Correct. I would say value is velocity plus variety plus volume. So the way you put up data, you can put up volume instead of that, and for speed you already have velocity. You can also put a variety. So has everyone understood these four V's? Can I get responses on these four V's? Yes. Okay. Okay. Instead of yes, you can also give me smileys. Okay. So we have Ravi. He has just joined in. Okay. So Ravi, I'll just do a very quick recap for you. We were talking about. I'll introduce myself. I'm Nidhi, presenter for today. Then we've just talked about big data. This is the first slide only. We were talking about that we have huge amount of data coming in from a lot of sources. We also have recording of this slide. We'll send it across so that you don't miss on anything. But just to set ground for this class, I'll quickly tell you that we have a lot of data being generated by a lot of random sources, and this data has to be stored and analyzed to derive some value out of it. So we were just talking about three V's. That is variety. We have variety of data coming in. That is, we have all unstructured data. We have log files, videos, images. So that is variety of data. It comes in at a very fast pace. That is, frequency of data coming in is great actually. Facebook generates data every day. Flights generate data every 30 minutes of flight. Then we have NYSE generating data every second. And then similarly for the power grid system. So that is velocity of data. Then you also have volume of data. First figure, if you can see, it says Facebook generates 500 terabytes of data. Though the figures have changed, but you can still take reference. So these are the three V's. We combine these three V's to derive the fourth one, that is volume. Sorry, that is value out of this all this data. So Ravi, have you followed? Have you understood what we were talking about? Can you respond in the chat window? Okay, so we have yes, I did. So I assume that we are good for the first slide. We'll move on to the next one. How about the file, says Avinash? That is just an analogy saying that these are government files, and I don't think anyone can help sorting out this data. Do you think anyone can help sorting out this data? Even if Arvind Kejriwal comes up in the politics, then also we'll have files and a lot of data. So I have a big no from Gaurav. Yeah, you are correct. I think most people will agree with you, but a bit lazy to write it down. They're going to be big and bigger. Correct. That is ever growing without a solution. Okay, so we'll leave it at that and move on to the next slide. Okay. So now we'll talk about what is the need, what is the challenge of this big data. We understand we have a lot of data and we process it, but there should be a challenge in dealing with a lot of data, right? So here we'll talk about what is this challenge. So we'll try to understand DFS, how it works. First we'll try to understand what it is. Okay, Avinash is great mathematician. Even before starting, he has come up with an answer. But still, Avinash, I'll give you a chance to explain how you came at that, or else you can allow your imagination to wander free for 10 minutes till I take the slide. Okay, so we have two images here. One on the left says one machine with 4 input-output channels, each channel consuming 100 MBs of data per second. Okay, or I should say not consuming, reading 100 MBs of data per second. Now we'll talk about how much time would it take to read if we were to read 1 TB of data with one machine. Guys, Avinash has already done mathematics and given me an answer. I would expect answers from all of you. So can I have that? A simple mathematics, one machine reads 100 MBs of data per second using 4 input-output channels. How much time will it take for this machine to read 1 terabytes of data? Okay, we have 1/10 of the time, Dhananjay. I'm still on the left image. I'm not talking about the right one. Seconds is not the. I don't want answer in seconds, Tushar. Can you convert it to minutes and tell me? Okay, I have a lot of answers. All those who have given me answers as 40 to 42 minutes, in the range of 40 to 42 minutes are correct. Exact is 43 minutes. We'll also go with 40 to 42. Avinash, since you were the first one to explain, to give me the answer, can you now quickly write it on the chat window, how you arrived at that? No, Tushar, 20 minutes is not the answer. We'll talk about how we arrived at 40 minutes. You want to formula. You can just quickly tell me how you did that, how you arrived at that. Okay, so till Avinash writes, I'll tell you, it is very simple. We have 400 MBs of data being read per second by this machine through 4 input-output channels. To read 1 TB of data, as we do simple calculation, we'll get it approximately 43. We'll keep it to in the range of 40 to 45. Yes. So is everyone with me? Has everyone understood how we arrived at that? Okay, Balvinder has given me exact answer, 43.69 minutes, very much approximate. Yes, okay, so everyone understands. Now the image on the right is even simpler mathematics. It says that if we distribute this data over 10 machines, it would be easier to read this data. Right? How much time would it take for 10 machines to read 1 TB of data? Can I have the answer here? 4 minutes, 4.3, correct. 4 to 4.5, correct. Okay, so we are good here. Now, what we derive from this slide is that it is easier to store the data. Storage is not a problem. If I have 1 machine, I can also expand my storage to 10 machines, and it is not a problem. It can be very easily done. So what is the problem here? If storage is not the problem, we see the problem is reading. Over the span of time, storage has increased drastically. Price of storage has come down. Today everyone uses external hard disks. Servers hard disks are have even lowered their prices. So, but the problem is that input-output of the disk, or the seek time of the disk, has not increased proportionally as it should have along with the storage capacity. So that is the problem. We can store data, but while reading this huge amount of data is a challenge. So one solution that we see here, as we saw in this slide, is that if we can read data parallelly, we can get good throughputs. Right? Is everyone with me on this point? That storage is not a problem, reading is a problem, and the probable solution is that if we store data on multiple machines and read it parallelly, we can get good throughputs. Yes, I have 2 quick responders, Ramesh and Rahul. Yes, Rajat, I missed on that. DFS stands for data file system. No, it is not data file system. It is distributed file system, because we are distributing data on multiple machines. Okay. So everyone is with me, and we'll talk about DFS. I'll take you back to the first slide when I was talking about introduction to HDFS. That is the title for today's session. HDFS is Hadoop Distributed File System. As of now, we have arrived at a distributed file system, and it will take one more slide to add an H to it to make it HDFS. So we'll first understand what is DFS. I have some question coming in. Give me a second, guys. So ultimately, Ashish is asking, so ultimately the seek time is what we are reducing here. Avinash, we cannot do anything about the seek time of the disk. It will be what it is. We are just combining, we are just distributing the data across machines to improvise on the throughput that we can derive from these machines. Okay, we are not improving on the seek time of the disk. We have just found a way around to go with it. Okay, so we'll start with the distributed file system. Okay, so here again you have 2 sets of images. One on the left talks about before DFS consolidation. Here you can see we have 4 physical machines, 4 different machines, and if we look at their names, they are probably located in 4 different locations, and they store data of 4 different categories. One is home directory, one is project, one is software, and reports. What it means is, if an end user wants to check data on projects or on reports, he'll have to connect to 2 different machines and get that data, right? So it is like you have one store in one part of the city and another store in another part of the city. Let's say if you have to buy grocery, you go to one end, and if you have to buy a computer, you go to another end and then buy it. So it's like that, right? You go to 2 different locations and get your data. On the right hand side, what we have is, we have a single machine, okay, and address for that machine is same. It says maxipedia.com, and we have public. Under the public domain, we have other all other information that we were accessing earlier on 4 different machines. So what it means is that now all your directories are booked under the same I would say same umbrella. Okay, so you just need to hit one URL and get everything from that URL itself. So it is like going to, instead of going to 2 different stores to buy grocery and computer, you go to a shopping mall and enter the shopping mall's gateway or the entrance, go inside, and then you find everything there itself. Right? So is that analogy clear, and do you now understand that what is DFS consolidation? So what we've achieved is we have combined several physical machines in under one umbrella. This is a logical combination. Data will still reside on 4 different machines, but we can access them through one URL. Right. Ramesh is asking, it is just mapping of for different file systems. Yes, basically they are present in 4 different locations, but we have just one machine, correct. Okay, so is everyone with me? Has everyone understood that what is DFS? We'll just go ahead and add an edge to it to make it HDFS. Before that, I need to make sure that everyone has understood big data and DFS. Okay, guys, I need more yes from you. Okay, only Ramesh is giving me a smiley. No one else is smiling at me. Avinash, did I miss your question? You are saying answer, please. Can you please repost? Someone till then I'll answer your question. How is consolidation achieved? What we do is we take a gateway, like the entrance to the shopping mall. We take a gateway server. All your requests will hit that gateway server, and from then on they'll go to their respective physical locations or the physical servers where data is stored. That is how it is. That is how consolidation is achieved. Okay, I have a question from Vamsi. Log files meaning machine generated logs. Yes, machine generated logs are example of big data and business data which may be in requirement documents. Technical design documents, these can also be called as big data. Yes, Vamsi, all the documents also come under big data, and we have several technologies to store and query this kind of big data. We might not be covering it in this course, but for documents we have a specific data store which is called as MongoDB, and it is used for analyzing documents. Okay, so data will still be in different location. What are we achieving out of it? Asked Dipankar. Yes, see, data will still be in different location, but what we are achieving is that we have just one gateway to access all the information. We don't need to hit different servers all the time, and we can distribute data to as many physical servers as we want. We can extend this project server. Let's say your project data grows and the particular server which was storing it earlier is not capable of storing all the data. You can shard that data or distribute that data to another machine, but still for your end user nothing changes. He just still hits the gateway and gets to your data. So that is what we achieve out of it. You can distribute data as long as you want. Yes, Dilip, MongoDB is a NoSQL database. I will not go deep into it. It is way out of line for today's session. Huge number of XML files can also be called as big data. It is definitely big in volume, Vamsi, but since XML files come under structured data, they are not used in Hadoop very frequently. You can analyze it, but I don't think it is a very potential use case. Okay, so I will now move on to make this DFS HDFS, and then we'll be talking about what all of you have paid for, that is Hadoop. We'll talk about that. Okay, so we finally arrived at what is Hadoop. Okay, so now you can see a very formal definition coming up on your screen. I will spend some time here because I want all of you to understand what, excuse me, because I want all of you to understand what it is about. Avinash, I'll ask my support team to get back to your question. I don't want to get into that because it will take a lot of time and might not be of interest to all our audience. Okay, we can take that offline. Don't worry about it. Okay, what is the difference between DFS and local file system? Dilip, can you? Okay, how do I say that? Your local file system is still just one disk or one directory, right? It is just one hard disk. Even if you expand it, but your DFS is it has multiple machines, and it is a consolidation in a way that it is accessible through from outside through one URL. Your local file system will still be and it is your local file system is accessible only to you, right? Or the user who is physically logged into that system. DFS is the kind of a setup which multiple people can access at the same time, and it works for everyone. Okay, so am I good to start with Hadoop now? Are we done on DFS? Can I get response from everyone that we can start on Hadoop? Okay, so some people are eager, asking me to start. Yes, okay, so I'll go ahead with it. Okay, so I'll read out this definition very slowly, and I'll I'll point out 5 terms in this definition which are of utmost importance. So how we'll go about it is, Apache Hadoop is a framework. Yes, we understand it is a framework that allows for the distributed processing of large data sets. So we have distributed processing, that is, we have processing is distributed across various physical machines of large data sets. So this point is of great importance, that Hadoop is suited for use cases where you have large data sets, where you need to work on large amount of data across clusters of commodity computers. So we have 2 terms here, clusters of commodity computers. Does everyone know what a cluster is? It is a group of machines grouped together. It's known as a cluster. Minimum is 1, maximum can be any depending on the requirement of commodity computers. So a cluster of commodity computers. What is a commodity computer? Vamsi, I'll come to your question. Let me finish this this definition first. I'll come to your question. Yes, commodity computer is a normal computer, any normal PC with not very sophisticated hardware. Yes, a computer like yours and mine. Yes, very much correct. That is a commodity computer. So we understand cluster of commodity computers is a group of generic computers using a simple programming model. Now this simple programming model is MapReduce in technical terms that we were talking about. We will be covering it in the 3rd week of this session, and it basically it can be accessed through several languages, but the most popular language to access MapReduce is Java. So that is why we say that you might have to learn Java if you want a little more understanding of that. Yes, so I'll run. I have talked about the 5 different things. I'll again read through this definition, just highlighting the points that we want to discuss. Apache Hadoop is a framework 1 that allows for the distributed processing 2 of large data sets 3 across clusters of commodity computers 4 using a programming model 5. So these are the 5 things that should fit in a use case scenario if you are thinking about using Hadoop for that particular scenario. Are these 5 terms clear on the high level to everyone? Yes. Yes, Suman, processing means storing, retrieving and analyzing data. Processing is retrieving and analyzing of data. Then Dilip asked me, we can use MapReduce on any other language. Yes, you can use Python. Python is again very popular for using MapReduce. I had another question from Vamsi. Apache Hadoop is different from Cloudera Hadoop. In the installation doc, it was given to install Cloudera Hadoop. Yes, Vamsi, we'll run you through that in second class, that is setting up Hadoop cluster. We'll talk about that. We'll give you a Cloudera VM and help you out in setting it up and help you understand how it works internally. We'll be looking at the configuration files, configurable parameters, and see in great detail how it works. For today's class, this is just an introduction to set grounds for understanding next classes. C++, I don't think, Avinash, it is a popular language for MapReduce, but Java and Python definitely are. Okay, so Vamsi has already installed. He's a step ahead of all of us. Great going, Vamsi. Okay, so we have this programming. Okay, programming model is not the point we'll be focusing on today. We'll be taking it up in great detail in third class. For today, we'll be focusing on that Hadoop is a framework. It does distributed processing of large data sets across clusters of commodity computers. Till here only we'll be focusing in today's class. By the end of this class, you'll understand how reads and writes happen into Hadoop. You'll also understand what is the underlying architecture and how it works. Okay, so some companies using Hadoop. Here are some of the names. Most big players are there. Yahoo was the pioneer in using Hadoop. It was the first one to set benchmarks in terms of the terabyte sort that it did on a 500 node cluster. Then we have Google using it, Facebook, Amazon using it. Amazon has anyone heard of Amazon Web Services? Please add Cisco to that list. Yes, definitely. I'll pass it on to our design team to do that. We are definitely one of the bigger players. Yes, we know Cisco is a big player in Hadoop. Yes, American Express too. Okay, so all other companies that we have can be found at the link that is given below. Yes, AWS offering by Amazon, correct. So Amazon has come up with a huge ecosystem that stands around Hadoop. It has a lot of services. I'll not get into details of it. I'm just saying that Amazon is a big player in Hadoop. It has come up with a lot of products and pretty amazing products. Now all these companies are out of India since we are today sitting in India, and we have some global friends joining us. I'll just take a few minutes to talk about something that we have in India. Does anyone know of any company using Hadoop in India, or any use case that was implemented in India? Okay, we have HCL and Aadhaar card, correct? Two correct answers I have. There was a very recent use case apart from Aadhaar which happened in India, which was a potential use case for big data and is being undertaken by what do I say, by Harvard University. Okay, has every Yahoo was the first one to implement Hadoop, Balwinder, and Google actually came up with the programming model that is MapReduce. That is innovation from Google. Okay, is everyone aware of Kumbh Mela that happened last year? Yes, so everyone is aware of that. So as you all understand, it is a 1 month program, and in that 1 month program in Allahabad, an entire new city is built. We have how do I put it? A lot of people moving in and out of the city, but tents are put up for particular days, and a lot of things happen there. So that was taken up as a potential use case for big data analytics by Harvard University to understand how people respond to such big changes, because since this is intentional, but it can also be of great help if we have natural calamity. We can take references how to create or build up a new city and accommodate people Okay, so Dilip says I love Allahabad. It's a great city, Dilip. I've been there. Okay. Okay, so Ambarish is from Allahabad, but he didn't know that it was a potential use case and was taken up by Harvard University. Great. Metro railway is also one of the use cases. Correct. Disturbance in the audio. Is everyone facing this disturbance in the audio? I'll check my connection again. Just give me a second. Is it better now? Okay, I've reset it. Is it better now? Can we go ahead? Okay. Okay. Okay, I'm sorry guys for all those who are listening a bit of echo or some background noise. Please excuse me for that. Okay, so it's good now. Okay. Okay, so so far we have talked about, I'll just keep summing up in between so that in case you have questions you can throw it at us and we'll try to answer. In the starting we talked about what is big data, we understood how it is generated. Then we talked about, we saw what is the challenge in dealing with big data. We understood the concepts of DFS and how it works. Then we moved on to understand Hadoop, and we also talked about the Kumbh Mela use case, and we had a lot of use case coming in from all of you guys. I must say that you're keeping it a very interactive session, and I'm particularly liking it. Is everyone else enjoying the session? I'm enjoying it very much. Okay, so I have smileys coming in now. So that feels great. Okay. Okay, so we are doing good. Guys, should I go ahead and ask for a hike in Aditeka? I'm doing good. Okay, okay, just on a lighter note. Dilip, we'll discuss your question in next slides. Don't worry about that. About data node and all, please don't introduce those terms right now. Let me go step by step. It's a great cut in my hike, Vamsi. You are giving me a positive response. I'll definitely go back and say that I'm getting a positive response. Okay. Okay, so we'll start with, we'll come back to the slides now. We will have this little conversation in between to keep the mode lighter for everyone. It's a 3 hours class. I don't want it to. I don't want your imagination to wander free. I want your imagination to be with the slides only. Okay, so we'll now talk about. We've understood. We have just introduced Hadoop. We talked about what are the 5 major components. Okay, Vamsi, that's a deal. He's saying that I'll settle for 5%. Yeah, sure. Do we get a break? Sorry, Ravi, I cannot afford a break in 3 hour session, but yes, we'll definitely have these little breaks where we'll talk about, where we'll just talk for a while. If it is something very urgent, you can go by, you can go and come join. As I earlier mentioned, we have recordings of the class. We'll send it across. Okay, you are just asking. Okay, fine. Fine. So I'll get started with the Hadoop core components. Sorry. What is it that makes Hadoop? Okay. So here we have 2 major components. First one is HDFS that we've been striving so hard to reach at since last few slides. And second is MapReduce. So guys, we'll be talking about HDFS first in today's class, and MapReduce I'll just touch upon it, but I'll not go into details. It will not. It is all set for the 3rd week class. We'll do it on that day. Even if I start on today, it will be too much of information to sink in. Altaf, have you just joined, or we had you from the starting? You say that I'm not getting anyone's chat messages. Is this a recorded session? Yes, this is a recorded session. We'll send the recording across. Don't worry on that. If you have any questions, keep posting. I always monitor the chat window and answer the questions. Okay. Java only used in MapReduce? Java is one way to use MapReduce, Vinay. Please don't get into MapReduce. All the questions on MapReduce will be answered on third class. For today, it's just enough to understand that there is a programming model to work with HDFS, and that is MapReduce. And there are several languages to work with it. One of them is Java, other is Python, and there are several others less popular languages. If you understand even this much, you are set for the day. You don't need to know much for that. Is Java required to learn Hive and Pig? No. Hive and Pig have their own syntax. You don't need to learn Java for that. Okay, so today we will just focus on what is HDFS. Diagram here, I would like to congratulate our design team for doing this. They have come up with pretty descriptive diagrams, and that also they have followed the color coding throughout the slides. In all the slides, you will see that you have red boxes denoting data nodes and blue boxes denoting name nodes. So on this slide, we'll just go very slowly, spend some time here and understand what these four components are and how are they related to each other. Sorry, Vamsi, this is, I would love to do that. I would love to tell you where Pig, Hive and Zookeeper are used. But that would be again an extended discussion. So probably I'll write back to you on that, or we discuss it on specific classes. Would that be okay? Am I audible? Yeah, I'll get back to you on this, Vamsi, after the session. I understand that you need those kind of discussions where it can be implemented, but I cannot do it right now. I'm very sorry. Okay, so I'll go ahead with the slide here. So we have actually we have a couple of boxes here, and we have 4 new terms. I'll go very slowly on this slide. We'll start from the left. We have admin node or name node. This is the master. This is also the master node for Hadoop setup. Okay. Then on top of it, we have job tracker. That is another component. Then we have in the red boxes, we again have 2 components, something called a data node, and on top of it, we have a task tracker. So here what we are trying to understand is that Hadoop has 4 things which are known as name node, job tracker, data node, and task tracker. Okay, so these are the 4 components that we have in HDFS or in Hadoop. Now, how these 4 things are related, that's what I'll talk about in this slide. But what these individual components are and what are they responsible for, that we'll cover in the next slides. Is that okay? Yes, so Ashish has put it up very nicely. These are 5 machines with Hadoop installed on it, 1 being master and 4 being workers. Correct. That is correct, Ashish, and all the installations we'll cover in the next session. We'll see how to configure a data node, how to configure a name node. We'll work on that. Supported OS for Hadoop. Believe Hadoop supports most OS. Linux is most popular, or Linux or Unix are most popular. You can work on Windows as well, but Windows does not have native support for Hadoop. You will need to install a simulator called Sigwin first, and then you can work on Hadoop. Name node and admin node are same. Yes, correct. These 2 nodes are synonymous with each other. These 2 are synonymous with each other. Physically, it is 1 machine. Okay, name node, admin node, or master node are the or the master are the 3 different names for the same thing. Balvinder says he has seen some diagrams where master also has task tracker and data node. Balvinder reports at site to someone. That is not correct. You cannot have task tracker and data node on the same on the master node until and unless it is not a pseudo cluster. Pseudo cluster is where you have just 1 machine and all the processes running on it. So that can only be the scenario. In a clustered environment, you will never have task tracker and data node running on master node. Once I'll come to that, what it does and what it does not do. We will talk about that in detail. Okay, so for this slide, what we need to understand is that we have a name node which is associated with a job tracker, and we have a data node which is associated with a task tracker. Does that make sense? From the diagram itself, we can remember that name node is associated with job trackers and data nodes are associated with task tracker. Second thing to get from this diagram is that there is only and only one name node and one job tracker, and there can be multiple data nodes and multiple task trackers. Did everyone follow what I just said? We'll discuss what a job tracker is. We'll discuss it in great detail. Yes, name node is a master node and data node is a slave. Correct, Dilip? Okay, Ashish is asking me to repeat. Okay, so we just need to understand that there is only one name node and only one job tracker in the cluster, but there can be multiple data nodes and multiple task trackers. Is this clear now, Ashish? Do you get this from the diagram? One name node, one job tracker, then multiple data nodes and multiple task trackers. Vinod is asking, is there high availability option and failover? Yes, we definitely have. We'll talk about it on the next slide. Job tracker and name node can reside on the same machine. Yes, it is one of the very popular configurations. They can reside on the same machine, but in production environments, we usually prefer to keep it on separate machines. Tushar, name node and admin node are not different. Admin node is just another name for name node. Don't take it as two different things. It is the same thing. We have XML as metadata. No, Ashish, metadata is not in the form of XML. Hadoop, name node stores it in the form of edit logs and FS image. These are just log files with the extension of log. We'll show it to you how these look like in the next session. Yes, Vamsi. In local installation or in a single machine cluster, which we call as pseudo installation, everything will be on the same machine. Correct. Maybe that is what Balvinder was referring to. That he saw a diagram where everything was on the same machine. Yes, task tracker and data node will always be one machine, Dhananjay. Or it is safe to say that task tracker runs on a data node. One task tracker runs on every data node. So again, safe to arrive at a conclusion that if you have 10 data nodes in your cluster, you will definitely have 10 task trackers. So can you please explain on the separation line, is asking Suman. Okay. Separation line is just a logical separation. On the top it says MapReduce engine. MapReduce engine interacts with job tracker, so that is why it is put there. And HDFS cluster is actually the combination of all these things that we have here. So all these four things, name node, data node, job tracker, task tracker, make up the HDFS cluster. Okay, I have a lot of questions coming in. Balvinder and Suman, I'll take up your questions in next slides. I will answer it through the content. If it does not get answered, please post it again. I'll take it up in next slides. Okay, so on this slide, are we good to understand that we have 4 components and they are related to each other in some way? Has everyone understood that? Okay, I have a very good question coming in from Ramesh. He says in previous slides we saw 4 different file systems located in 4 different locations. Are these 4 data nodes also those 4 physical locations? Ramesh, these are not those 4 physical locations, but yes, these are 4 different physical locations. We'll see and we'll cover it in the next slides how these 4 different locations are determined, how data is stored on them. Like how do we determine which node to store data on? Okay, so is everyone with me on these core components? Please don't try to understand everything in one shot, let's go step by step. Let's just understand that there are 4 components and there is only one name node and only one job tracker, multiple data nodes and multiple task trackers. Okay, can I have quick response from everyone, because we need to move on, guys, and we need to understand that this is just 4 components related to each other in some way. Okay, so we have an all good here. Okay, we'll go ahead. Now we'll talk about what is HDFS. So we have finally added an H to the DFS that we were talking about, right? We have made distributed file system. We have now made it Hadoop distributed file system. Okay, so I had this question: is there any fault tolerance in Hadoop system? To answer your question, Hadoop is highly fault tolerant system. How this is achieved, this we'll talk about. We'll go a step back when we were referencing to the definition of Hadoop. There we saw that we use commodity computers, right? So what we do is, since storage is not a problem for us, all the data that we have, we store it in multiple physical machines. Okay, so since these are commodity computers, they are not reliable. They can go down anytime. There can be power outage, there can be any network failures, or there can be hardware failures. Anything can happen, and data might become unavailable if it was stored or just on a single machine. But for us, since we are using commodity computers, storage is not a problem at all. And what we do is, we store this data across multiple machines to make it fault tolerant. Okay, so default factor or default multiple copies of data in HDFS cluster is 3. It is a configurable value. You can reduce it or increase it depending on your requirement. Then, so the system is actually always available, because there is a very little chance that all 3 machines will go down at the same time. That is not going to happen, right? So your Hadoop system is highly fault tolerant. Yes, Ramesh, it means that same data is stored in minimum 3 machines. It is default is 3. I would not say minimum 3. Default is 3. It is configurable. You can either increase it or reduce it depending on your requirement or depending on the criticality of the data. No, Balvinder, data node capacity of each data node is not same. You can have machines of different configurations. But yes, if you have 10 TB hard disk for a machine, it can store only that much data. It cannot go beyond that. But it does not mean that all the machines in your cluster should be of the same capacity. You can have different configurations across your system. Means minimum 3 data node is required. Correct. If you set your replication factor to 3, or if you set multiple copies to 3, you need to have minimum 3 data nodes. Any disadvantage if we distribute on all machines on the cluster? Yes, definitely it would be a wastage of storage. If 3 works for you well, why go and store it on 10 machines? You'll be paying on storage and also on network. What if name node goes down? We'll talk about that in detail, Dhananjay. Hold on to that question for now, please. Okay, I have a question from Dipankar asking about the security of the data stored in commodity computer. Security of the data happens, all the communication that happens across the cluster between the several components is authenticated using some mechanism. I would not go into details of what mechanism is used in which transaction, because for different transaction, different security mechanisms are used. We have MD5. We also have Kerberos authentication. So I'll not go into details of that, but data is secure. All the communications happen over secure channels. And how do these data nodes communicate with each other? They communicate through SSH. Avinash, you are going way ahead. You are telling me answers from even before we have started. Okay, so I'll give you a chance to answer the question when we reach those slides. Okay, Balvinder is asking, is that master nodes 3 copies available, or it's only for data node it's 3 copies? Only for data node it is 3 copies, Balvinder. Only data node store data. Name node does not store any data. What is SSH? Tushar is asking. Would anyone like to answer that? What is SSH? Can anyone explain, Tushar, what is SSH? Yes, it is a secure shell. Tushar, it is a protocol for machines to talk to each other. For now, I can tell you that you can for more assistance you can either reach back to us or you can reach back to Google to find out what how it is and how it works. Okay, Avinash is also saying you can Google. Okay, so we understand that system is fault tolerant. How it is fault tolerant? That all the data is stored in multiple copies. Yes, Sriram, it is a default like that. You will not see chats from other people. You can write chats and even only I will see to it. So it is safe to ask any question that you want to ask. Others will not see what you are asking. Yes, Ramesh, if you are storing data in if you are storing your FB data in 3 machines, you do an update. It will be updated in 3 machines. Correct. Ravi, you have sent me a question mark. Did I miss something on your question? How to determine the number of nodes? Number of nodes will depend on the capacity, will depend on your use case, Ravi. You first need to identify, you first need to estimate the data that you might have across across the application, and it is not a hard how should I put it as? It is not a hard number to decide from the day one. It is a highly scalable system. You can add data nodes as and when required or take them down as and when required. So you need not worry on how many data nodes you should put up. Let's say if it increases, you can increase the data node. If your data load decreases, you can bring your data nodes down. Balvinder, I'll talk about what happens if master node goes down. I'll talk about that. Hold on to that question, please. Is there a monitoring system that allows me to make an informed decision? Asked Ravi. Sorry, Ravi, I did not get your question. What kind of monitoring are you looking at? You can definitely check the health of your machines, like health of data nodes. How much capacity is there? How are they processing? How are they behaving? You can definitely check that. There is a UI. We'll look into details of that UI in next class. On the number of nodes, Ravi, you need not worry about that. Let's say if on the initial projection is that data will be around let's say 10 terabytes over a period of a month. Okay, so you can go around and add machines which would suffice for 10 terabytes of data. Let's say you can safe to say that you can add 10 machines, 1 TB capacity each. That will work for you. Get the idea of the load and determine the nodes. Ravi, I would repeat it again. You don't need to decide on the number of nodes right away. It is a scalable system. You can add nodes as and when required. Vamsi will come to that. What is the disadvantage of using small files or small data sets? I'll come to that question. CLI is there, Ashish. We have UI. UI is actually a HTTP page that is projected for each of the processes that we run, and there you can check what is happening in the system. Okay, so okay, I have a lot of questions coming in, guys. I believe that all these questions will be answered in the next 3 slides. If they are not answered, please get back to me. Please repost your questions again. Is there a way to discard old data which is of no more use? Yes, Ramesh, you can delete data from HDFS. It's very much possible to add and delete data. Okay, I'll move on to the next point. Dilip says he cannot hear me. Is it same for everyone else? Others can hear me? Am I audible to everyone? Okay. So I'm audible to everyone. Dilip, can you please check your internet connection and get back? Okay, so till Dilip replies, I'll just get a quick confirmation from all of you if you've understood that Hadoop is a highly fault tolerant system. If we store data on it, we need not worry that our system will ever become unavailable. Data will always be available. Does everyone understand that, and does everyone appreciate this concept? Okay. Everyone is giving me smileys and yes. Avinash says yes if we get the job. Are you looking for a job, Avinash, in big data? Oh, he is. Okay, no problem. You'll crack your interviews, man. You are way ahead of all the answers. Even before I ask questions, you have answers ready. I don't know how you do that. You do some magic there. Okay, so Vamsi has given me 3 yes with a smiley. Great. So, okay, so we have a highly fault tolerant system. Next thing, what is the next advantage of Hadoop is that it gives us high throughput. Now, what is throughput? Can anyone quickly give me on the chat what is throughput? It is parallel reading, data in and out, output, efficiency, output per second, data per second. Yes, correct. It is or transactions per unit of time. Exactly. Yeah, that is the exact definition. Transactions per unit of time, or the input per unit of time, output per unit of time. So it is basically, to understand in a layman's term, throughput is termed as how many, how much data, quantum of data that can be read in 1 unit time, and quantum of data that can be written in 1 unit time. So that is throughput. Now for reads, we have already seen that since HDFS allows parallel reads, it definitely gives us a very high throughput for reads. And I'll add here that Hadoop is a system built for reads only. It is we can write it. It works on the concept of BOM, that is write once, read many. So you write data once and you read it multiple times in one shot. So it gives a very high read throughput. And write throughput is, I would not say it is bad, but it is not very great also, because writes are sequential here. Sachi, I can see your chat messages. Did I miss on something? I'm very sorry if I missed on something. A lot of people keep thinking I might have missed what you wrote. Can you repost what you wrote? Okay, till she writes, we'll move on to the next point. So we have talked about Hadoop is highly fault tolerant. It is high throughput system. It is suitable for applications with large data sets. Now Hadoop is a system we've been talking about. It is suited for large data sets. Now comes the question, what happens to the small files? Why is it not suited for small files? Issue here is that architecture of HDFS is such, or Hadoop is such, that it stores metadata about each of the files. Okay, and this metadata is stored in RAM. Which component does that? Let's not get into it. Let's just understand that Hadoop stores metadata about each of the files, and it stores it in RAM. Okay, and storing data in RAM is not a very cheaper operation. It is quite expensive to store data in RAM. And I have a lot of questions coming in again. Guys, let me finish it up, and then I'll take your questions. So for large data sets, if you have, say, TBs of files, you will have metadata will be small. But if you make files in, let's say, MBs, if you split a 10 TB file in MBs, 1 MB, 10 MB, 50 MB each, and try to store metadata about it, your component which stores all this metadata will be buggled up with all the metadata, right? and storing in RAM is anyways an expensive operation, so it is not a good fit for small data sets. Is this point clear? Has everyone understood? Yes, Philippe, metadata stores on RAM for good read. You've written it as seed. I would take it as good read. Okay. Okay, so I need to repeat it. Okay, I'll go again. See, let's understand it in this way. In Hadoop architecture, we have a component that stores metadata about the files that we put onto HDFS. Is that clear? Avinash and Ashish, are you able to follow me? Okay. So we have files about which metadata is stored. If there are large files, okay, there is metadata per file. Okay. So if you have one file which is of 10 TB, you will have just one metadata entry. Okay. If you split this 10 TB file into chunks of MBs and you try to store metadata about each of these files, it will be a multiple files, right? If you split it in MBs, let's say you split it into 50 files. Now instead of one metadata entry, you will have 50 metadata entries. Okay, so storing 50 metadata entries instead of one metadata entry in RAM is not advisable at all. So that is why we recommend Hadoop for systems where data sets are large. Do you follow it now? Is it clear? Okay. So, okay. What should I repeat, Namsi? Which particular part is not clear? Basic requirement for name node machine is that it should be a high-end machine with very good RAM. Again, configurations would depend on your data. Yes, 50 small files would mean 50 metadata entries, correct. And it's not just one-time metadata entry. Any update or any operation that happens on this file also contributes to metadata. So it is an ever-growing data set. When we are talking about data sets, say 1 TB, are we talking about one file with 1 TB size or multiple files totaling 1 TB? That was the point I was making, Vansi. It is good to have large files. It is good to have files in size of GBs instead of MBs because it contributes to a lot of metadata. Definitely you will not have one file ranging in 1 TB, but you can definitely have files ranging in GBs. You can have multiple GBs in one file, like you can have a 50 GB file or like that and store it on HDFS. Does that make sense now? So the baseline is that you should have large files instead of small ones and preferably in GBs to help Hadoop perform better. Yeah, Vinod, you can go ahead and solve this problem. Then we can remove this from disadvantages. Vinod says that it seems like an opportunity to research on how to handle smaller files in Hadoop. Vinod, I would like to make a point here that it can still handle smaller files, but it is not a good fit for smaller files. That's what we are saying. It does not mean that if you give it a file which is in MBs or even KBs, it will not process it. Hadoop will definitely process that file, but it will be a trade-off in performance. Okay, Suman has given me some use case. Can we say that mainframe machines can be the good candidate for migrating to Hadoop? Yes, if you are looking forward to reducing a lot of cost from paying deep-pocketed money to mainframe systems, you can definitely migrate to Hadoop. I would like to mention that today a lot of companies are actually moving from mainframe systems or from Teradata or to Hadoop. We see a lot of use cases wherein people come and ask about should we migrate or should we not. So it is not that always Hadoop will be a good fit for these systems. It always depends on what the use case is. What is the future of Hadoop? Asked Dilip. Dilip, Hadoop came in. Hadoop is not a very old system. It came in few years back, and it has been growing like anything. It is not just Hadoop that has been growing. It has brought in a set of multiple technologies, multiple. It is a huge open market. Every day you see a lot of technologies coming in. We don't say that it is just Hadoop. We call it as Hadoop ecosystem, and even we'll be covering some of the ecosystem components in this course itself, like Big Hive. All these are ecosystem components, and so it is like you bring one thing into the market, and then other people come in and interact with it to make it larger and better for a larger audience. That's how it works, and that is the future. As of now, it seems to be an ever-growing technology, and will serve us good in terms of in terms of jobs for coming at least 15 years. So anyone who gets a job in big data is a good fit all for 15 years, I would say. Does financial section fit in Hadoop? No, Avinash, it does not fit in Hadoop. Why it does not? I'll cover that up in next slide. Okay, so are we clear on the first 3 points? Highly fault tolerant, throughput, and suitable for applications with large data sets. Okay. So next is streaming access to file system. That is, we read a lot of data in one shot. We stream the entire data in one shot. It works on the concept of, as I already said, write once, read many. So that's what we'll do here. Can be built out of commodity hardware. This is we have covered multiple times. I don't want to repeat it here. So let's just do a quick check if everyone is clear with advantages of HDFS or the features of HDFS. Okay. No, Ashish, name node is not a commodity hardware. I'll come to that. And Vamsi, to answer your question, I'll just do that in 2 slides down. Avinash is asking for an answer. What was your question, Avinash? Why we cannot do parallel writing? Can we customize writing? I'll come to that. Okay. So here we have another definition coming in. It says, you can read it for yourself for a minute and see if you can get something out of it. Okay, so HDFS is the file system. I hope everyone has read it. Okay, everyone has read it, good. So HDFS is a file system designed for storing very large files. We saw why it is designed for very large files. With streaming data access is when you read a lot of data in one shot, running clusters on commodity hardware. This we know. So are we good with these 3 points? These 3 underlined points, is everyone in sync? So you can only do streaming data access, Tushar. That is what Hadoop is meant for. Okay, someone wants me to repeat. Okay, so HDFS is a file system, Suman, that is designed for storing very large files. We saw why do we store large files and why small files are not a good fit. Because it stores metadata in RAM. Then we have streaming data access, that is we read a lot of data in one shot. Then it runs on commodity hardware. So that is the design of HDFS. Streaming data access is when you read a lot of data in one shot. That is, you have entire file loaded onto HDFS and you read most of that file in one shot. It's not like reading line by line that file. Hadoop is not a good fit for reading line by line. And that is why it is not a transactional system. It is not a good fit for financial systems wherein you need to read one line, update one line of data. That is not possible in Hadoop as of today. People are working around it. We are coming up with new systems every day. It might be a possibility tomorrow, but as of today, it is not possible. Just like YouTube to stream. Commodity hardware. Vinay is asking me commodity hardware. Man, where were you? Were you listening what I was talking about commodity hardware? Commodity hardware is any generic, that is okay, I'll repeat it for you, no issues. Commodity hardware is a generic machine like yours and mine, which does not have sophisticated hardware. It is a normal machine. Okay, so Vinay is good with commodity hardware now. Is there anything else that is not followed, that is not clear till now? Okay, I have no answers on that, so I'll assume that everything is clear till now. Now, this is where some of your answers will get answered. Sorry, some of our questions will get answered. Areas where HDFS is not a good fit today. First is low latency data access, wherein you need to read data line by line, update one line, or scenarios like financial scenarios, banking scenarios. There, HDFS is not a good fit at all. You should not go for HDFS in those scenarios. It will not work for you. Then lots of small files, wherein you have lots of small files, don't use HDFS. Workaround would be that you merge those small files into large files and then use it. But then, depending on the use case, it is not always possible to combine all the small files into one and work on it. Correct. For low latency data access, we can use RDBMS. Very much correct, Dilip. Does everyone understand that? For low latency data access, RDBMS is a good fit. Okay, so yes, Suman. Suman is asking me a quick question till he types in. Okay, he has already typed it. What about data warehouse systems to make some market pattern research? That is a question from Sachi, business intelligence. Yes, Suman, you can derive business intelligence out of Hadoop. It is a batch processing system. If you want that, you feed some data in and you get the answers within seconds of time. That would not be possible for Hadoop. It is a batch processing system. You archive all the data, run your business intelligence code, and you will definitely have answers. You will need to analyze data processing line by line, but it is not that you will go and update one line and then come back. You will be reading all the data in one shot, run aggregates over it, and then get the data, right? There is a difference. It is a data warehouse, yes. Is Hadoop aim to create data warehouse? Yes, it is a great data warehouse wherein you store a lot of archival data. Okay, so we are good with Suman's question. Sachi also asked me a question. What about data warehouse systems to make some market pattern research? You can do that, Sachi, but then traditional data warehouses come at a very expensive licensing model, and also they take a lot of time to give you results. So the trade-off here is that Hadoop is cheaper and it gives you answers quicker than your databases. Okay, so we are good on the first 2 points, low latency data access and lots of small files. Third one is multiple writers, arbitrary file modification. Now, okay, so multiple writers and arbitrary file modifications, what we mean here is that when we write, guys, please pay attention to this point, it is very important. When we write data to data nodes, it is always appended. Whatever files we have, data is appended at the end. Because of this reason, we cannot allow multiple writers to write at the same time, because you do not know where the first writer ended, right? So it is like first writer will end and then second writer will write. First, second writer ends, then the third writer will write its data. So applications where you need multiple writers writing in data, in those scenarios, Hadoop is not a good fit because of this writing model. Writing cannot be parallel, it has to be sequential, otherwise all your data would be messed up. Sachi says that it means any data warehouse systems can be converted to Hadoop. Again, Sachi, it would depend on your use case. It can be a good fit depending on the data criticality. Like you cannot make your banking data warehouse system into a Hadoop system. That would not be a good fit. Sorry, Vamsi, I've not heard of this tool. But there are a couple of ETL tools that come with connectors for Hadoop and we can use them. Multiple, yes, Tushar, multiple users are using it, but they are not writing data to the same file. Right, data writing on the same file would only be sequential. It cannot be multiple writes on the same file. Can we customize taking sync into consideration for writing? Sorry, Avinash, I did not get your question. Can you rephrase or be more elaborate on that? Multiple writer scenario, I'll talk about it. Let's say you have one file, okay, residing on one data node, okay, and you want to write to that file. Or let's say you have two writers who want to write to this file. First writer comes in and starts writing, okay. Now data has to be written in a way, it has to be appended. First writer ends and then second writer writes, okay. But if you allow two writers to write at the same time, second writer will not be able to determine where the first writer ended, right? So that is why we cannot have multiple writers writing in. We have a sequential write on the same file. It does not restrict from us from the scenario wherein multiple other files being written, 10 files being written in a system is okay, but one file being written by 10 users is not okay. Yes, correct. Correct, Suman. Banking, for banking financial organizations, Hadoop is not a good fit. Okay, so Avinash got his answer. I think we have answers for everyone. Can we go ahead, move on from here? We have a lot to cover and I think we are running short on time. Okay, so we'll talk about HDFS components here, name nodes and data nodes. These are the slides wherein I will cover what is the configuration required for name node, and I'll also cover how why it is important to make it a high-end machine, and we'll also see what data nodes do. Okay, so here we'll talk about main components of HDFS. We have name node coming up with an image of a very high-end car, Lamborghini. So okay, it is the master node of the system. As we already saw in previous slide, it is the master of the system. It maintains and manages the blocks which are present on the data nodes. Now read through it again. It just says it maintains and manages the block. It does not say that it stores the block. Okay. Now this is a very important concept here, that name node does not store any actual data. It just stores the metadata. There is no actual data stored on name node, and no data ever passes through a name node in any of the transactions that happen between the components. Is that understood? I will repeat it again. I know it is a different strange concept. I will repeat it again. Name node is the master of the system. It maintains and manages the blocks. It does not store any actual data. It only stores the metadata. Okay. All the data is stored on data nodes, and no data will ever cross name node in any of the transactions that happen in the system. Are we good here? We'll talk about how requests are handled, Ashish. Is this the point I just made? Is this clear that no data ever crosses name node? It just stores the metadata in its RAM? Yes, it contains metadata and not the data. Very much correct. So this is a high-end machine. You can also use the image to remember that it is a high-end machine. We have shown a Lamborghini here. Okay, moving on to the data nodes. Data nodes are slaves, or data nodes are yellow ambassadors. As compared to Lamborghini, they don't stand anywhere. Okay, so that is the analogy between the name nodes and data nodes. Data nodes are slave machines, which are slaves are deployed on each machine and provide the actual storage. So name node stores just the metadata, and data nodes store the actual data. They are Kolkata taxis. Yes, Ashish, they are Kolkata taxis. Okay, Kolkata traffic is very bad, but has anyone been to Kolkata? Oh, Dipankar is from Kolkata. Do you like the traffic there, Dipankar? Vinod says, I don't want to be in a Abu Dhabi Lamborghini police car. I would love to be in a yellow taxi. Yeah, Dipankar also agrees that Kolkata traffic is bad. Okay. Okay, let's not talk about the traffic. Traffic between the data nodes is good. They talk nicely over SSH. So here we don't have a traffic problem, but in Kolkata, yes, we do have a traffic problem. Okay, okay, Dilip, we'll discuss other transportation options in Kolkata offline. Let's just talk about name node and data node here. Okay, so data nodes are slave machines. They store actual data storage, and they are responsible for serving read and write requests from the clients. So these are the machines wherein from where read and write will happen. Is that clear? Through name node, no reads and writes will happen on actual data. Any reads and writes on the actual data will happen only through data nodes. In what scenarios does data nodes talk to each other? We will come to this question, Avinash, please hold on to it. For now, is it clear? Are the points that I made on name node and data nodes clear? Is the analogy of Lamborghini and taxi easy enough to remember? Ramesh, I did not understand this smiley. Are you giving me a bad face or is it a good face? Okay, so everyone understands what it is. Okay, going forward, we have talked about 2 components. Do you remember from this slide where we saw 4 components, name node, data node, task tracker and job tracker? We have already seen 2 components. Herein we'll see other 2, that is job tracker and task tracker. Apart from job tracker and task tracker, here is also another slide which, sorry, not another slide, another component which is named as client. Okay, so how do these 3 systems interact with each other? We'll start from the top echelon. We'll start with the client. So client is any application or program that interacts with the system. Okay, then there is a job tracker. This client talks to the job tracker, and job tracker is actually a kind of a manager for all the task tracker nodes. Okay, where does the task tracker run? Can I have a quick response so that I know how we did on the previous slide? Where does this task tracker run? Okay, Avinash is the first one to answer. He says data node. Okay, slave machine and data node. Correct, very much correct. Okay, so job tracker manages all the task tracker. When I say it manages all the task tracker, I mean to say that it keeps a check on which task trackers are alive and which task tracker has how much work to do. And how do these task trackers work? They use map reduce programming to work or to analyze the data. Now what is map and what is reduce? Don't get into it. Just understand that it is some programming paradigm which helps us to analyze the data. Is that clear? Are we good on the slide? Or do we have questions here? Okay, Dilip is asking that metadata is stored on RAM. Where does all the data node information store? Data node actually stores all the actual data, so that will be stored on your data nodes. Is your question answered, Dilip, or were you asking something else? Map and reduce are a part of the programming model. Map, reduce, Rajat. We'll talk about it in 3rd class. For now, just understand it is a programming model that is used for analyzing data. No, analyzed data output is not structured, Vinod. It is still unstructured. Okay, good to go for next slide. how job tracker identify which task tracker needs to be called. We will see that in detail, Sachi. Please hold on for a few minutes. Once I missed your first post, what was it? You are saying that in the hard disk, not in RAM. In data node, store data in hard disk, not in RAM. Is this what you were referring to? Yes. Okay. Okay. You were correct. Data node stores data in hard disk, not in RAM. Can you please repeat the client's role? Okay. Client is any application, Dhananjay. It is any application like what should I say? It can be a jar file for which contains your business logic. It can be that, and it interacts with the job tracker. We'll see how this interaction goes on. We'll see that in next slide. It interacts with the job tracker, and then job tracker sees to it that the task that the job is run successfully on the task trackers. We'll see client's role in detail in upcoming slides. So this is one slide, and after that we'll talk about job tracker's role. My web application can be a client. If it is trying to analyze some data on your Hadoop, it is doing some interaction with Hadoop, then yes, your web application can be a client. Raveen is saying name node stores data in RAM. Yes. Okay. So here we have a very important slide, HDFS architecture. I'm sure you will have a lot of questions on this. Let me complete what I have to say, and then you can come up with all your questions, because many of them will get answered when I'll talk about it, when I'll continue on this slide. I'm sure a lot of questions will get answered in that course itself. Okay, so I'll go again. I'll go very slowly on this slide. I'll cover each of the terms here in detail, and then I'll combine all of them to make the big picture. Okay, so I'll start with client that we were talking about. So again, client is an application or a program that interacts with HDFS cluster. It can interact with name node. It can interact with data nodes also. Okay. In the previous slide we saw it interacts with job tracker as well. So next term in the slides is rack. We have two racks, rack 1 and rack 2. Now what does rack mean? Can we have answers from you? I'm sure most of the people know what a rack is. It is physical set of storage, collection of nodes. Correct. It is a set of storage, collection of nodes. Multiple nodes are bundled into one rack. Rack is and here to put it as rack is a collection of data nodes. Correct. Each of these data nodes will be are different machines, are different physical servers, which are located in one physical location grouped under a rack. Is that clear? Is the concept of rack clear? It is a collection. Can we say rack is same as a cluster? Rack is same as a cluster. Rack can contribute to a cluster. Yes, it is a group of computers. In that, if you go by that analogy, rack is a cluster. But any group of computers become a cluster when they are connected in some way. Okay, so we'll go with it that rack is a physical storage of computers, and in this case, it is a collection of data nodes. They can be in same or different locations, Samsi. Depends again on the criticality of the data. What is the typical configuration? I will cover that in slides later. We will see how these data nodes are stored in which rack. We have a very interactive slide for that. I'll walk you through it. Moving forward, we understand what are data nodes and we understand what is a name node. Apart from that, we have something called metadata operations. So do we understand what a metadata is? Metadata, everyone knows, is data about the data, right? Okay, so Ashish says he understands what is metadata. Okay, we know the saying data about data, correct. So we have already seen that name node stores metadata, that is, it stores information about the data that is stored on data nodes. Okay. Apart from that, it also stores data about anything that happens to these files. If there is a read operation, there is a write operation. For every operation that happens in the data, name node makes a new entry. Job tracker will come in the next diagram. This one is just to understand the interaction between name node and data node. to keep it simpler and understandable, we have omitted the job tracker from this slide. I can make it more detailed, but then it would be all buggled up. Okay, Shrikant is asking me to explain with some example metadata. Okay, example metadata would be, okay, I'll talk about it now in a bit detail. So please can I have your good attention here? Okay, so whatever files you put onto HDFS, these files are broken down into blocks. Okay, now this block size typically for an HDFS system, it is 64 MB per block. Okay, and if you had a 1 GB of file, you will break it down into 64 MB blocks, and these blocks will be stored on data nodes, of course replicated as per the replication factor. For now we will say 3 times. Okay, so your file is broken down into blocks of 64 MB. These blocks are stored on data nodes and they are replicated thrice. So what name node does is, name node stores the information that which all blocks make up a file. Okay, let's say a file was broken down into 10 blocks. So name node will store that which are the 10 blocks which make up this file. Let's say your file was named sample.txt, and that sample.txt was broken down into 5 different blocks. Okay, so name node will store information that block 1, 2, 3, 4 and 5 make up sample.txt. Okay, it will not store the information as to on which data node this block is stored. Am I clear on that? What kind of information name node stores? Guys, this is a very important concept. Have you followed block size is configurable or is it limited to 64 MB? No, Vamsi, it is not limited to 64 MB. It is configurable. It can also be 128 MB. The larger the better, but we go for 64 MB always. Yes, you can also use 128 MB. Correct, Didi. Okay, apart from block size, are we good with the concept that I just relayed? That name node stores information about which blocks make up a file. Linux is 8192 bytes. It is definitely, you can do the math to find out which one is smaller or which one is larger. Okay, so Vinod says yes, he has followed. Has everyone else followed? Can I have response on this, or do I need to repeat that? So Ramesh, I don't understand this smiley. Is it a good one or a bad one? It is a good one. Okay. Avinash, I'll answer your questions. Please allow me some time, please. Yes, bigger the block size, better it is. Okay, so everyone has understood that name node stores information about which blocks make up a file. Now the next question can be how to decide on replication factor. That will depend on the criticality of your data, Dhananjay. Default is 3. It is a configurable value. You can set it according to your requirement, according to your use case. Okay, so now we'll talk about, since the data is stored on data nodes, right? Each of these blocks will be stored on data nodes, and name node has information, only the information that which blocks of file, which blocks make up a file, right? So how does it know that which block is stored on which data node? It does not store that information, right? It is not storing where block is actually stored on a data node. Right, Gaurav has summed it up for me. You are correct, Gaurav. That is correct summary. So data node stores this actual data, but name node does not store this information as to which block is stored on which data node. Then how does it know that which block is stored on which data node? How this is carried out in HDFS architecture is that every few seconds, again a configurable value, default is I think 2 or 4 seconds. Every few seconds, data node will send heartbeat messages to name node saying that this is the block map that I have, these are the blocks that I am storing, and it will send this report to name node. So name node knows that okay, this particular data node is alive, and this is the these are the blocks that it is storing. So now it gets two kind of information. One, it has already stored which blocks make up a file. Second, it continuously keeps getting information which data node has which blocks, right? Combining these two information, name node can tell a client where to go for which data node to go to access the data. Is that clear? Do you mean data node sends info to name node? Yes, data node sends info to name node in the form of a block map. They send the information that these are the blocks that I'm storing. That particular operation is not shown here. Name node also replies with heartbeat messages, and what this slide shows, Vamsi, is that it is showing block operations. Name node tells which block of information is to be stored on which data node. That also name node decides. How are blocks identified? That is the storage architecture. Will blocks have a name? They have some identifier which is not very good to memorize. It is the long ID. It does have some IDs. Yes, it is a part of it. Gaurav is asking, is block operation same as block map in this slide? Yes, block map, sending of block maps, and then name node telling the data node or telling the client where a particular block should be stored on which data node. That constitutes block operations, or any operation dealing with blocks. Reading of blocks, block maps, writing of blocks constitutes a block operation. Does name node send ACK for the heartbeat message? Yes, Avinash, it sends ACK for the heartbeat message. Sometimes it also tells data nodes that these are under-replicated blocks. So you go and replicate this to this particular data node. That also happens in the name node ACK heartbeat. How client decides which blocks to read? Okay, Dhananjay will cover this question in the next slide, how client decides which blocks to read. As of now, is it clear what is metadata and what are block operations? What kind of information name node stores? Is that clear? Name node is not meant for the purpose of storing data, Sachi. It just stores the metadata. If it stored everything, there would have been no concept of DFS. It would just be one machine storing everything. Yes, there is a socket connection between name node and data node. Okay, Suman is still not clear about how blocks are identified. Okay, I will go about it again. How blocks are identified. Okay, so first thing to understand that name node stores information about a file in a way that which are the blocks that make up this file. So we have a file, let's say sample 5, and it has 5 blocks, block 1, 2, 3, 4, and 5. So name node will have a mapping. Name node will have a mapping saying that this file makes up 5, these are the blocks that make up this file. Okay, and then you will have data nodes sending in regular reports to name node saying that these are the blocks that I am storing on my disk. Okay, so combining these two operations, combining these two set of information, name node can say that this block is stored on this data node. Is that good now? Suman, is your question answered? Okay, fine. Okay, Avinash, two data nodes communicate over SSH, and between all others are socket communications happening over TCP. Is that clear? So inter data node communication is SSH. Okay. So we have covered pretty much here. We understand, so a client does read data from a data node. It also writes data to a data node. Neither does it read actual data from name node, nor does it write actual data to a data node. So that is HDFS architecture from the point of view of name nodes and data nodes. Is that clear now? Can we move ahead? Can one file consist of blocks of more than one node? Tushar, your question is not clear to me. Can you please elaborate? One file can have multiple blocks, that is correct. And one block, what are you asking? Okay, till Tushar comes up with his rephrased question, I'll move ahead. Are we going to come back to replication or blocks? Do you mean to say that it is not clear and I need to repeat it, or how do you want to go about it? What is the client's role here? Client is just an application that is in reading or writing data to data nodes. Okay, Ravi is asking me a question. He's saying we have 1 TB of file broken down into blocks. How is this done? Okay, we will see that. We'll see that how it is done. Okay, apart from this, what all we discussed, those points clear? I can understand a lot of questions come into mind when we represent this slide. It is very obvious because it is a gateway to a lot of other concepts. Okay. So we'll move ahead. Now this is starting from here. Next two slides are quite typical. So we'll talk about the functions of job tracker here. We have a lot of boxes on this slide. We'll go in detail, and it might be possible that not each one of you will understand it in great detail because there are a lot of concepts bundled up here, and it might not make a complete picture in the first go. Please don't worry about it. I'll anyways repeat it twice. But still, if it is not clear, please get back to us. We will give you this material. We'll give you this recording. You can go overall again, and then it will definitely make more sense. But it is very much normal that these concepts don't sink in at the very first time. It always happens. So don't worry. It is a step-by-step procedure. We'll go about it in detail. Okay. So first thing is we have a user. User is like you and me, who copies some input files to DFS. Now what is DFS? DFS is our HDFS system or the file system. Okay. So user copies some input files to HDFS. What these input files will constitute is it will have a jar file. It will have your client code basically, or the MapReduce code, or any code that you want to execute. It will that you want to put on DFS, which is required for running your program. Is that clear? What copy input file means? Am I audible to everyone? My voice is breaking. Is it better now? You can't hear me. Okay, I'll repeat it again. Okay, so it is better now. Okay, so this is the slide where we'll talk about job tracker. Okay, so we'll copy some input files to the DFS. We understand what DFS is and what are the input files. What these input files will constitute is, it will constitute of a MapReduce code. It will constitute of associated jar files with the MapReduce code, and it will also have any other files that are required for executing the code. Is this point clear? Copy input files. Rajat, please be with me. Don't jump to XML and jar files. We'll talk about it. What are job XML and job.jar? Okay. So Vinay says he has understood. It is confusing. Input is actual data files. How user can copy input files? Okay. There is a way to copy files to HDFS. There is a command line through which we can copy files to HDFS. That is how we copy files. Okay, I already said it will not be very clear. I'll make my best efforts to make you understand. Let me go about the entire flow once, and then we'll take up questions. I think that would be good. Yes, Dipankar, it can be the case when we say we are copying input files. We can either be copying data or the MapReduce program, or we might be copying both. We might just copy MapReduce program in scenarios where data is already there and we need to analyze that data. In those scenarios, we'll only copy MapReduce programs. But if we are in a use case wherein we need to give data and code at the same time, in those situations, we'll be copying both of these. Where do we copy input files, name node or data node? Sachi, no data is ever stored on name node. So anything that you put it onto HDFS goes onto data nodes. MapReduce does not copy data to data nodes. MapReduce does not hold data. It is just a processing logic to analyze the data, to work on the data. It does not hold any data. Data is different, and MapReduce is the computation that has to be performed on that data. Is this concept clear, that MapReduce is only computation, it is not data? You copy the code at the time of processing to a data node to run it. You basically put it on the HDFS, and how it actually works we'll see. So I'll move ahead. I think your questions will be more clear. For copying, you can use simple CP command. No, you cannot do that. There is a separate command line for HDFS. We'll be using that. If I could give a simple example, it would be it is the HDFS file system, which is called as FS. So once we install Hadoop, we run commands as let's say if you want to copy data, we'll just say Hadoop FS. Then we say copy from local, that is we are copying a file from our local system, copy from local, and we give a HDFS file location. When you copy input files, do we see logs of it? You can do a ls on the system and see if that file has been copied. And yes, there are logs generated for all the processes. You can check from there also. No, Rajat, copying does not mean from master machine to slave machine. It means copying files to slave machine, and the only metadata about these files is stored on master machines. You will not store data on master machines. You will store it only on the slave machines. Okay, so moving ahead, user first copies the files onto VFS. Then it submits the job to the client. That is, it tells the client that I have a job to run. Then, sorry. So this, what this client will do is, it will go to the DFS and see what are the files, what is the information, or what is the job that has to be run. Then, depending on the job information, it will create splits here. Now, what are the splits? Suppose you said that you want to process a file. Okay. Now, this file, if it is a huge file and it cannot be processed in one shot. So this client will split this file into into smaller chunks of data, so that these can be processed by individual processes. Okay. So once these splits are created, about this information about this splits will go to the DFS. Okay, this job information will be uploaded, that these are the splits created and this is the data that needs to be processed. Okay, then client comes back to the job tracker and gives job tracker the information that, man, this is my code. Okay, it has already submitted the jar file. It will tell the job tracker that, man, this is the file, this is the computation I need to do. This is the data where it has to be done, and I have created the splits also. So client will submit all this information to the job tracker. From now on, job tracker will take up the job and it will process it. How it does that, we'll see it in the next slide. But client's role is threefold. First is it gives information of the jar file. It gives information of associated directories. It gets the information. It creates the splits on the files, and then it gives all these combined information to the job tracker. Is this, did you follow what I said? That what is the role of client to put the files, to understand where the data is, and to create splits and to give it to the job tracker. Is it clear? Is client part of DFS? No, it is not part of DFS. It is a separate entity. Okay, it is clear to some and not clear to some. Okay, client has to upload data and code as well. Uploading data might not be the case all the time, but yes, client has to upload the code every time. Data might be existing. Let's think of a scenario wherein you have already, there is a system wherein your data comes in every day. Okay, at some predefined frequency, your data comes in every day, and at the end of the day, you run a batch query on it to learn that how much, how was the sale that day. Okay, that is a batch query. But in this scenario, you only need to give the code because your data is already there, right? So Rajat, does that make sense to you? The data can be existing and we might just need to send the code. Yes, submitting a job means firing a command or a query, correct. And these are the, what we just discussed was all these steps, creating splits, giving it to the job tracker are the internals of what is happening. When we'll read about Hive or Pig, we'll just see that we go and give the query to the client and it runs it. We do not, at that point in time, we do not go through all these steps. We just submit the query, that is a job, and we get back the answer. I'm sure all this will definitely make a lot of sense when we'll work on Hive. Are the splits equivalent to blocks? I would say that splits, number of splits is equal to the equivalent to blocks. Yes, it is. Like splits has to be of the size of the block, and it actually determines that on which data node it has to go and process the data. Split is chunk of data actually. Who will create a client? Okay, who will create this client? This is the client that we will create. This will be a Java program, let's say a Java application program that we write to interact with HDFS. That becomes the client. Number of splits equals to number of maps. Correct, Dilip. That is very much correct. Gaurav is asking me to go step by step again. We need to specify the file name. Only we will automatically shard the processes to splits. Rajat, I'm sorry, I did not follow your question. We need not take care of splits in HDFS. Your client will automatically create splits. You need not take care of that. You need not worry how many to create, how many not to create. Okay. So moving on, here we just saw that client submitted some job to the system, created input splits, and then told the job tracker that, man, I have this job, please go and run it. Now what does job tracker do? We'll see that in the next slide. Okay. So what is job tracker doing here? Again, I would repeat that again you'll have a lot of questions here. It might not be very clear to all of you, but please try to be with me. I'll try to make it clear as best as I can. So what has happened so far is a client has submitted the job to job tracker. I think we are good so far. Are we? I'm looking at my chat window. If anyone responds that we are good. Okay, so I have a couple of responses that client has submitted a job to job tracker. Okay. Give me a second, guys. Just arranging my window. Okay. So client has submitted the job to job tracker. It is saying that here is a job and I want you to run it. Okay. Now what does job tracker do with it? Okay, so what this job tracker does with it is in step 6 it takes the job. In step 7 it initializes the job in the job queue. Now what is a job queue? See, job tracker is one for the entire cluster, right? We saw that in the previous slides. And there will be multiple clients interacting with HDFS, correct? At the same time. So all these multiple clients will keep pushing their jobs to job tracker. So what job tracker does is it maintains a queue wherein it keeps posting all the jobs in a queue, and on first come first serve basis it starts processing these jobs. Okay, now what are these jobs internally? As we said that every processing that happens on a HDFS cluster is a map reduce job. Okay, and map reduce is nothing. Map reduce is maps and reduces. These are two separate phases of the map reduce program, maps and reduces. So we've already seen in the previous slide that number of maps is as good as the number of input splits, and there is another concept called reduces, which is not determined as of now. Like we don't know how many reducers will be there for how many mappers. We just know that mappers will be equal to the number of splits. Okay. So what happened is that a client submitted job to job tracker put it in the job queue, and it understands that there are some mappers and reducers. There are some mappers and reducers to be executed. Then moving ahead, we see that now how does job tracker know that where is the data? Okay, it needs to know where the data is, right? If it has to run processing on your on the files that came in for a day, it needs to know where that data is stored, right? Who will give that information to the job tracker? Who knows where a file is stored? Can I have answers so that I can understand who all have followed? Okay, I have answer from Ashish saying name note, and Milind and Avinash. Okay, many people have given me the correct answer, so I'm not doing a bad job. Guys, am I doing a bad job? I have received a couple of correct answers. Okay, so job tracker will go to thank you, Vinay. Job tracker will go to name node and get the information that where this data is stored. Okay, so that becomes your step 8. It will also read the job file and job.jar to know what it has to do. Okay, client just told it that I have uploaded the file and I have created splits. It did not tell the job tracker that this is the actual file. It just said that I have uploaded it. So job tracker goes to name node and reads the file and also gets information on what data is to be processed, where it is stored. Okay, so it comes back and creates the maps and reduces. Now what are maps and reduces? Maps and reduces are two phases of the map reduce programming model. We'll understand them in detail in upcoming slides in next sessions. For now, just understand that this is a programming technique wherein we have two things called map and something called a reduce. Is that okay? For now, just understand it is a programming technique. MapReduce code will be placed on the HDFS itself, and as we know, whatever we place on HDFS goes to the job tracker can submit the job simultaneously to NameNode and MapReduce. So job tracker is not submitting the job to NameNode. Job tracker is just reading some information from the NameNode, and it is keeping job information in a job queue. Okay, so far we have seen that when client submits the job to the job tracker, it goes to NameNode, gets the information about the job and the data to be processed, and it creates maps and reduces. Maps and reduces are nothing but programming paradigms which analyze the data. Then moving ahead, this is the last one. This will answer your question. I had a question that how job tracker determines which task tracker will run which task. Okay, so I don't remember who asked me this question, but I had this question. So please listen to what I say next. It will answer your question definitely. So here we have a job tracker, and it is showing a job queue. So it picks up the data, it picks up the task which has to be done, and picks task data local if possible. That's what it says here. Now before I move on, I'll talk about the task tracker itself first so that we understand where are we going. Task tracker is one process, okay, which runs on every data node. Okay, now this process, what it does is it internally has task slots. Okay, it would be safe to say that, let's say every task tracker has 5 slots to run, or that is it can accept 5 jobs at a time, 5 tasks at a time. Okay, and task tracker is running on a data node, right? So it would be good for a task tracker if it gets a task where data is locally placed on its data node, correct? Otherwise it would incur some network to go to the data node, bring that data in and then process it, right? So instead of doing that, that is the responsibility of the job tracker to determine that which data it should, which task tracker it should pick up. Okay, so let's go about it in this way, that job tracker got a job wherein data was stored in data node 2. Okay, so it will first of all go to data node 2, check the task tracker running on that data node, and see if it has some task slots empty. If it has, well and good, it will give that task to this task tracker and say that since data is stored on your data node, please run it and give me back the results. Okay, so that is what is happening here. We'll start with step 10 here. It says heartbeat. Now, as we saw earlier, data nodes were sending heartbeats to name nodes. Similarly, task trackers send heartbeats to job trackers. In similar fashion, they say that I am alive and these are the slots that are open with me. These are the jobs I am running. This kind of information it will keep sending to job tracker. How does it help job tracker? Job tracker always knows that, okay, this is the task tracker that is alive. This is the status of the job. And if it does not hear from the task tracker for some time, it will go ahead and kill all the processes running on that task tracker and assign it to someone, a heartbeat. So this is how task tracker will come to know that which task tracker has how many slots empty. Once that is determined, depending on the job data, it will pick a job and give it to one of the task trackers. That is H1, H2, H3 or H4. We'll give it to any of the task tracker depending on the data locality. Now, it picks up the data local. How it will determine? It will try to determine a task tracker wherein data is stored locally. If that is not possible, it will try to assign it to the nearest task tracker so that network bandwidth incurred is less. Then once it has determined the task tracker, it goes and assigns the task to a task tracker. This is assigns the task. Then once the task is assigned, task tracker will run it and keep informing the job tracker so that job tracker knows what is happening in the system. Now coming on here, I have moved on to the next slide, but I need some responses from you so that I can understand what is happening. Okay, Vamsi says it's all bouncers. Did anyone understand what I was talking about in job tracker and task tracker allocation? Okay, for some people it was clear, for some it was not. So I will just repeat this one. To make a complete picture, let's go just step by step. In the first slide of job tracker, we talked about that a client submits a job to the HDFS system. It uploads MapReduce code and associated files in the system, creates the splits and tells the job tracker that, man, I have submitted the job, now please take it forward. So what job tracker does is, job tracker takes the job, then it goes to the name node and checks what is the file uploaded. Name node will have information about which file is uploaded. File will be on a data node, but name node will provide the information that this is the file that has been uploaded. Okay. Job tracker will not go to the data node, will not go and check each of the data node where the file is. It will just go to the name node and say, man, give me the address to where this client has uploaded, which file this client has uploaded and where it is. This is the information that job tracker will go to get from the name node. So it will get that information, and after this is what we meant when it says read job files. It will get that information from there, and based on the input splits already created, it will create the mappers and reducers, and then after that it will do the main job of assigning task to task trackers. Are we good now? Is it understandable? Job tracker is not a part of name node, Ashish. These two are two different entities, and they can even be located on two different physical machines. These are two separate processes. Okay, so I get a better now from Vamsi. Okay, so I have improvised on the explanation. It takes some time to sink in all these concepts. It is I understand it. It takes time to understand what goes in and about. And I would suggest that you go over this recording again to understand what we are talking here, or you can also read some of the points on your own. And if you have any doubts, you can always get back to us. We'll answer your doubts. But please make sure that there are no doubts when we move on to the next class. If you have questions till then, please keep writing to us. We'll be very happy to respond and help. Task tracker and data nodes also on separate machines. No, Ashish, task tracker and data nodes run on the same machine. Do you remember the first diagram where I introduced these four components? Their task tracker and data nodes were on the same machine. Dipankar asks, Heartbeat will be a continuous process to keep name node updated, isn't it? Yes, Dipankar, bang on. That is correct. This is to keep name node aware of the entire system. So you can think of name node as a big boss that needs to know what is happening in each of the subordinates or each of the slaves. That is how name node is. Name node and MapReduce run on separate machines. Yes, Dilip, MapReduce runs on data nodes because that is where data is. What will a MapReduce run on name node? Name node just handles metadata. It does not have any data. So there is no sense in running MapReduce on name node. MapReduce has to run on machine where your actual data is stored. Yes, correct, Ashish. When we say data locality, it means processing MapReduce jobs runs on the data node where data is stored. Correct. So that is how the concept of Hadoop is. It sends computation to the data. MapReduce is your computation, and you send that computation to the data. Okay, so moving ahead, now that concepts are a bit clear, I need a quick response on this particular slide, job tracker and task tracker. How job tracker knows which task tracker has a slot and how it assigns jobs. Can I have response on this one? Yes, Ramesh. User submit MapReduce job and later task tracker run the same MapReduce. Correct. You got it right. Ashish is saying that I can go and tell my seniors that I am doing a good job. A good man. If I could show this to my seniors, I would definitely get a good appraisal. I will do that next time. Okay. Okay. So this slide is good. Okay. So moving ahead, now we understand that how a client submits the job, how job tracker takes it up, and how it determines the task tracker to which job has to be assigned. Okay. What happens next? Now the job is with the actual workforce, that is with the task tracker. Now what will the task tracker do? So job tracker assigns task for execution to the task tracker. Okay. And on the right side of it, it says maximum map slots and maximum reduced slots. Okay. So what this is about is, see, we need to understand that each of these processes, task tracker, job tracker, name node, data node, all these are separate Java processes. These are JVMs, individual JVMs that run on the machine. Okay. So task tracker is a JVM, and each of the task slot that it has. Okay, I'll put it in this way, that this big purple box is one JVM. Okay, and this one JVM is capable of spawning child JVMs. So what you see here is these are the task slots. Okay, so these task slots will again be individual JVMs. So it is safe to say that one task tracker JVM can spawn multiple or child JVMs where your task will run. Nitin, I can definitely show all these components in one slide, but then it would become very, very confusing to understand how it happens. Dilip is asking what is JVM. Can I have answers from anyone who worked on Java? What is JVM? Ravi, these are individual JVMs, not threads. Purple box is one single JVM running on a single machine, Ashish. Yes, JVM is a Java virtual machine. It actually provides you a Java environment to run a Java code. That is a JVM. Okay, so your task tracker is one big JVM, and this JVM is capable of spawning multiple child JVMs to run your actual job. Yes, Nitin, I will share that offline. What are the blue boxes? These blue boxes are task slots or the child JVM, and this is where your actual job will run. Now, how many child JVMs a task tracker can spawn? That is a configurable parameter. There are separate JVMs, like separate slots for map and separate slots for reduce. Now, these two are configurable parameters in the configuration files, and depending on that, task tracker can spawn the JVMs. Now, once it gets a job, once task tracker runs the job, it reads into its local disk, because that is where it will find the data. Okay, so this DFS here represents the data node. It will read the data into local disk and and it will run the job. So that is how your job is run. So here we talked about submitting the job, and then we went deep down to executing the job. So is this slide clear? I understand it is a lot of concepts bundled in a few slides, but then that is how it has to be. Okay, I get a clear from Avinash. Okay, what is job.xml and job.jar? Job.jar is the Java code containing the computation logic, and job.xml is a file that has some information about job.jar. We'll see it exact contents in the third week. Don't worry on the contents, what it contains. We'll do a hands-on. It will all be very clear then. What is happening? What is job.xml? What is job.jar? All this will be very clear. Can task tracker in one node read the data from other nodes in DFS? Yes, Tushar, I would say it is possible, and this is the scenario where two data nodes communicate over SSH. That is, they have to bring in the data from other data nodes to their own local disk and then process it. Okay. So moving ahead, we have talked about the job tracker, and we'll be moving on to next is the task tracker cluster. Sorry Ashish, can you elaborate? Is the task tracker cluster? It is a part of the cluster, but is it a cluster in itself? I don't get that question. Okay, Ashish is taking some time to respond. It is a single machine, so one JVM must be running. Yes, correct. On a data node, one JVM will always be running. That is your task tracker is one JVM. It will always be running. Correct. Okay. So till now we have. I'll just sum it again. We talked about. We understood the concept of Hadoop. We talked about the advantages and disadvantages, or good fit and bad fit for HDFS. We talked about the role of a job tracker, or the very important role of what happens when we submit a job to HDFS system, how it is run. Rajat is saying explain multiple JVMs. See, Rajat, I will go back to the slide here. Your task tracker is one JVM running always on the slave machine. Okay, do you follow that? The task tracker is one JVM running on data node. Yes, you follow that. Now this task tracker has to run some jobs. Okay, these jobs will be given to the task tracker by a job tracker. Do you follow that? That the task tracker will get jobs from the job tracker. Avinash, till I go about this topic, you can take a 2 minutes break. No issues. If you have understood the concepts, you can take a 2 minutes break. Okay, so it gets the job from the job tracker. Then each of the task tracker has some task slots. Okay, for the discussion purpose, I'll say that it has 4 task slots. Okay, that means that at a time, one task tracker can run 4 tasks. Okay, or they are safe to say that there can be 4 tasks running on a data node. Since okay, so all these 4 slots are individual JVMs. These 4 task tracker slots that we talked about, these are 4 individual JVMs, and these JVMs are spawned by the task tracker. Does it make sense now? So they can be child threads, right? Sorry, they can be child JVMs. So depending on the number of jobs, JVM will get created and destroyed automatically. Yes, Ramsey, depending on the number of jobs, they will be created and destroyed automatically, but they cannot go beyond the particular parameter that we configure through these two values, map slots and reduce slots. Are we good now? Okay, so job tracker has actually taken a toll on our brains, right? It has many concepts got bounced off. Then we will discuss them again and again, and still I understand there will be some gaps. You will need to do something on your own as well to understand. Sorry, Rahul, it is, you say it is too much for the day, but it has to be this way. We have a few more concepts for the day. Once you've understood this one, it will not be very difficult going ahead. We just have a few slides, and we have a very interactive slide coming up, so that is a relaxer actually. Okay, so I will go ahead, assuming that everyone has understood what happens when job is submitted. Rajat is saying for each job tracker. Rajat, did you mean task slots? Because job tracker is only one in the system, and it is only one JVM. It is task slots that can be multiple. Yes, you are correct. there can be their separate environment will be provided for each of the task slot. This is because so that if one task slot fails, it does not affect the processing of the other task slot. For this reason, to keep processing this joint. Okay. So moving ahead, we saw submitting a file to the submitting the job to the client, submitting the job to the system, and how it behaves. Now we'll talk about how a new file is created. Okay. So we have a user, we have a HDFS client. HDFS client, for now let's take it as the HDFS command line. Okay, that is the HDFS client for this slide. It is a HDFS command line. Now user wants to add a block of data to the cluster. Now what will it do? It will go to the client and say that I want to add this block. Now what happens is when we write a block of data, it has to be written to a data node. Okay, and before writing, it just cannot enter the system and write data to any of the data node, right? It has to go to name node first and ask the name node that where can I place my data? Which is the data node which data node do you recommend to place this data? So it will go to this name node, add and ask it for location where it can place the data. Name node will tell the user where it can place. Then it will go to that particular data node and start writing the blocks of data. Now what client will do is it will write only to the first data node, and since there is a replication factor of 3, this data node will take care of writing it to the next data node. And this particular concept of writing to the other 2 data nodes, this is called as replication pipelining. Okay, so what happened is HDFS client wanted to write the data. It went to the name node, asked for a particular location or asked for a particular data node where it can go and dump that data. Once it got that information, it went ahead and wrote that data to the data node 1. And this data node 1 took care of replicating these blocks to other 2 data nodes. It gave it to another, and this another guy went ahead and gave it to another data node. So this became a replication pipelining. Okay. So once data node receives all this data, what it does is it will send acknowledgements to the cluster, or sorry, it will send acknowledgements to the name node that I have received these blocks. Or how will it send these reports? How does data node communicate with the name node? Can I have answer on that? How does data node tell the name node that I have these blocks? What is the mechanism? Heartbeat. Yes, correct. Gaurav, you've got it correct. No, SSL is not the thing. It will tell the name node through the heartbeat. Correct, by sending heartbeats. Correct. So that is correct. We've got an answer. Okay, Dilip, you have put up a very good point of Dilip says, is this slide clear? I'll take up your question once the slide is clear. Can I have response on this slide? How write happens? Is this clear to everyone? Guys, am I audible? I'm asking if this slide was clear. Okay, everyone got this. Okay, so now I'm introducing, Avinash is asking me a question if we run below command. Avinash, let's just hold on to HDFS commands for this class. It is introductory class. We'll run all the commands in the next class. Then you can boast about all the commands that you know, and you will understand how and why they work in that manner. Okay, so Rajat is asking what happens when a node fails during replication pipelining. Okay, if a node fails during replication pipelining, its name node will come to know that a node is down, some job has failed, and it will go back. Client will again have to go back to the name node, get a new location, and start writing all over again. So that is how it will work. Okay, and now on the question of what is a secondary name node, I'll talk about that. we were saying that name node is a high-end machine, should be reliable, stores all the data, and through these slides we have always also seen that name node is a single point of contact to know where files are stored. If it goes down, what basically happens is we do not have any address to the data locations where the data is stored. So we need to have some reliability mechanism for the name node. For that, what we do is we have a second system in place, that is secondary name node. What the secondary name node does is, it is also a sophisticated machine. It stores some data that is on name node, but then it is a highly misnomer. It does not take up the place of a name node. If a system goes down, secondary name node cannot come in and take the place of a name node. That does not happen at all. Please pay attention to this point, that secondary name node is not a replacement for the name node. It is just a backup agent. What it does is, at some points in time, it goes to the name node and takes backup. And let's say backup was taken at 4 p.m. I'm coming to that point, Deepankar. Let's say backup of name node was taken by the secondary name node at 4 p.m. and going ahead at 4:30, name node went down. Okay. So and the secondary name node was scheduled to take another backup at 5 p.m. So at 4:30, it did not take any backup. It just took a backup at 4 p.m. So whatever happened between 4 and 4:30, that data is lost. There is no way to recover that data. Okay. If we bring in the secondary name node in place of name node, we'll have the status of the cluster as it was at 4 p.m. But the updates that happened between 4 and 4:30, they will be lost. Is that clear? Does this backup happens only once? No, it is a configurable value, Ramesh. You can configure it. You can configure your secondary name node to take checkpoint at a desired frequency. Backup of all metadata. Yes, Ashish, it is a backup of metadata. That's what your name node stores, and that is what secondary name node takes backup of. There is, unfortunately, there is no way to control this loss as of now. We have as in today, we have Gen 2 Hadoop coming in, which takes up the place of which is active passive system for name node and secondary name node. So when name node goes down, secondary name node takes its place. But that is not a very popular system as of now. Not all organizations have implemented it. I believe it is still under beta phases and being being prepared for production releases. This is not high availability. Ashish says that with a very sad smile, that this is not a high availability. See, Ashish, high availability is maintained in terms of fault tolerance. When we copy all the data to thrice to the data nodes, we maintain fault tolerance. And name node, this is why we make sure that name node is a high-end machine so that it does not go down. If it goes down, then that is definitely an unfortunate day for that particular organization. Yeah, correct. Ambarish puts this correctly, that it is a Lamborghini. You have to rely on it. Okay. So guys, we are running short on time, and I'm afraid I'll be extending this session by at least 20-25 minutes. Would that be okay for you? Since this is the first class, it always takes time for the concepts to sink in. Okay, Avinash and Gaurav says okay. Ashish is also okay. Does anyone have a problem? Okay, so it seems it's okay for everyone. Oh, I'm so sorry, Vinod, it's already late for you. Can you please bear with me for another half an hour? Okay, it's late for Vamsi as well. Yes, Sachi, you are right. Okay, let's just continue. I'll try to wrap it up as soon as and as efficiently as I can. Okay, so second please. Okay, so this is where we'll talk about how data nodes are, how blocks are placed on nodes. Yes, Ranjit, please go ahead with your question. What happens when one data node gets fails during process in the network or crashes? When a data node fails, Ranjit, name node will come to know that a particular data node has failed because it will not receive heartbeat messages from it. At that time, name node will initiate replication of data on that node to other data nodes. So that is how failures are tackled. Is that question answered? If when we have backup, Ashish, how will you take a backup at 5 if your name node is down at 4:30? What will you take backup of? Okay. So okay, so here is a slide that talks about rack awareness. Title is rack awareness. Let's just ignore it for a while, rack awareness. We'll just talk about the concept here. We have multiple blocks, right? And each block is replicated thrice. So here we are trying to find out what is the placement strategy followed to place these blocks on physical machines. Okay, so we have 3 blocks A, B, and C. And we have 3 machines here, 3 racks here, rack 1, rack 2, rack 3. And each of the rack consists of 4 machines. Rack 1 is 1 to 4, 2 is 5 to 8, and then 3 is 9 to 12. So what happens is, when let's say, how will block A be placed? So let's run through the slide. So block A comes and lands in first server of rack 1 or the first data node in rack 1. Okay, now we need to identify where will the other 2 replicas go. Okay, now here is you'll have the answer of how the system is fault tolerant. Avinash says it will go to 6 and 7. It seems he has how right he is. No, you were right with one. Another one went for a toss. It is 5 and 6. So okay, the number doesn't matter. What matters is that we place the first replica on rack 1. For second and third replica, we went to totally different rack. So this gives us a high availability system, which says that if rack 1 is down, we still have 2 different replicas on rack 2. Okay, so that is what makes the system highly fault tolerant. Now there will rarely be a scenario wherein rack 1 and rack 2 will go down simultaneously. And then again an unfortunate day. Why not in 6 and 9? It can there is no point in storing the data on the 9th rack leap. Sorry, Ambarish, it doesn't make sense because it will be highly distributed data, or I should say that it will incur a lot of network bandwidth if you have to read from the replicas at the same time, because that is what happens, parallel reads from the replicas. So that will incur a lot of network cost. And also it will be, I believe it is a wastage of storage when you can achieve the same point in storing data in rack 2 on different servers. Why go to a different rack and store there? So moving ahead, we'll see what happens to the block B. Block B goes to 6th server in rack. Avinash has put it up nicely. He says closer the data node, easier to write. Okay. So now we have block 2 landing in server 6 of rack 2. Now can you guys tell me where will the, I don't need the correct numbers, so just tell me which rack or which server. Okay, Avinash says 10 and 11, Gaurav says 11 and 12. Siddharth is able to hear me? Rack 3, 9 and 11, 9 and 10, says Ramesh. Your voice is breaking, says Tushar again. 2 and 3, says Suman. Okay, that is good. So, am I audible? No, is it possible for you to like? Okay, Dipankar says he can hear me. Okay, Ravi says it is okay now. For the block B, we placed the first one on 6, and then I asked you where would the other replicas go, and I got correct answers saying 1, 2, 3, 4. So that is good part is that one replica is on one rack and other two replicas will go on a different rack. It can either be on rack 3. So everyone answered correctly. Let's see how this is placed in the slide. So here replicas are placed on slides 10 and 11. So that is on a different rack. Similarly, yeah, Avinash is bang on. Yes, man, you got the correct answer. Okay. So block C comes and lands in rack 3. So other two should go to either. This concept of rack awareness clear now? How blocks are placed on data nodes? So, was this concept too much? Or okay, so only Gaurav says yes. Has everyone else not followed what I was talking about? Maybe for the same file or for the different file, doesn't matter. We are just talking about the blocks where they are placed. Ranjit, I'm not sure if it is a problem completely at my end or some problem at your end. Some people are able to hear me clearly. Okay, Dipankar says there was repeated for you. The point I was making is that when we place blocks of data, we place one replica on a rack and the other two replicas so that is they land up in rack 2 in servers 5 and 6. I don't know what to do with this audio connection. I'm connected to the internet fine. Everyone is facing issue with audio now. I'll just reconnect. Give me a second. Is it better now? I reconnected. Okay, it's better now. Nitin says it's time to go. You'll have to bear with me for next 20 minutes as well. I'm sorry for that, but can't help it. Okay. Rack 1 and 2 copy on the second rack. Yes, Dilip. 2 copies on a separate rack and 1 copy on one rack. Okay. So going next, we just have 2 more slides. Here we'll see how to write the file and then we'll see how to read the file. Easy enough concepts, and I think we'll be able to finish it off quickly, and then we can call it a day. But then we'll again go. We'll make sure that everyone understands what it is about. Okay. So here Dipankar says, why isn't a blue block on rack 1? See, Dipankar, block B has gone to rack 2 for one replica, and other 2 replicas can be on a separate rack, so it has gone on a rack 3. It can also be on rack 1, doesn't make a difference, it just has to be on a different rack. Is it clear now? Okay. Okay, so anatomy of a file, right? That's what the slide says. Here we'll see how a file is written to HDFS system. So we have a HDFS client. We'll call it as the HDFS command line. Then we create a file. Okay. Now what happens when we create a file? We go to the name node and I'm sorry, I missed it in between. There is a HDFS client and we create a file with it. Now this file, it goes to the name node and says that name node, I want to write a file. So name node again will give you the information as to on which data node you can go and write the file. So HDFS client will come, write it to some stream and give that packet to a data node. Again, here also we have the concept of replication pipelining. This client just writes it to a data node and data node goes ahead and writes it to two other data nodes. Okay. Now once it is written, it will give an acknowledgement message back to the data nodes that okay, I have copied the data. Data nodes 2 will tell the data node 1 that I have also copied the data. It will go back and tell the client that your file is now copied. So that is how writes happen. Now this stream will go and tell the client that you can close the stream. Data has already happened. And once all this happens, once data is on the data node, next time when data node send the block report to name node will come to know that this operation is completed. Client will tell the name node that this operation is completed, and it will also come to know of the blocks when data node send the report. If one replication fails, then name node redo it. Yes, Ramesh, if one replication fails, then name node will redo it. Name node will come to know that this replication has failed, and it will again tell this guy that you have to copy it again, and the process will start all over again. Which components programmer has to code? Programmer here does not code anything, Ramesh. He just creates the file and fires a command on the HDFS client. All this happens internally. You don't need to do anything, code anything in this. Client program, this particular client here is the HDFS command line. It is not a client program. It is not a programmed entity. It is just a client, HDFS client. Okay. Okay, so are we good to go ahead? Suman says we have to execute jobs only when we try to analyze. Just for reading also you can do that, but that might not serve a good purpose. Analytics is the basic use case for Hadoop. What is the difference between create and write? When we say create, we just tell name node that this is the file. Then name node will tell us where to write it. We will get the address of the data nodes where to write it, and then we go and actually write the data on the data nodes or onto the HDFS cluster. So that is the what do we say, write operation. Okay, so are we good with the file write? Has everyone followed? Okay, so we'll move on to the next slide. Okay, here we'll talk about how to read a file. The earlier slide that we had, that was anatomy for file write. Now we'll talk about file read. Gaurav is asking me to explain something. What is your question, Gaurav? What is FS data output stream? It is a stream of data, or you can think of as a stream that helps you write data to a data node from your client. Okay, I'll go to file read operation now. What happens in a file read? FS output stream is a class, Gaurav. It provides you some functions to write data to a data node. Okay. Okay, so again we just talk about the file read here and then we'll be done with the session. So then we can call it a day. Okay, I'll quickly go about it. Here again we have the HDFS client or the HDFS command line. So we create a file. First thing, we get block locations from the name node, that where this block locations will be stored. We read the file. We create output stream to read the file. Go to data nodes, and here the difference is that we are reading the data parallelly from data nodes. Now it is important to understand that data nodes have replicated data, but we still read data from all the replicas and make sure that we are reading the same data and apply some checksums to check that whatever data we have read is consistent. And once that data is with us, we return it we have already read the data and we call it a close operation. So that is how read works. Read is actually pretty simple. You create a file, get the block locations from the name node, go to those data nodes where it is stored, read the file parallelly, and then close the operation. So reads are pretty simple. Vamsi, for today's recording, you will get it on your registered email IDs. Don't worry about that. We'll relate to the entire class. In case you have questions, you can write it to support@edureka.in. We'll get back to you. One block is read from multiple nodes. Yes, Rajat, we replicate, as we saw earlier, we replicate blocks of data on multiple nodes, and we read these data from multiple nodes at the same time. File read and write are different tasks than data analysis, correct? Yes, they are a part of data analysis. You'll have to read some data to analyze on it, and once you've analyzed, you'll also need to write that data somewhere if you want to store it on HDFS. How can HDFS client know which name node to be read? There is only one name node, Suman. Are you referring to a data node which has to be read? Name node is always one in the cluster. It is just a representation, Sachi, just to say that we read from multiple data nodes. We have 2 lines there. It can also be 3. Suman, there are not multiple name nodes. We have only one name node, and data nodes are multiple. How redundancy is taken care? Redundancy is taken care when you read from multiple replicas, and you whatever you have read, apply checksums and ensure that this is the correct data you have read and return it to the client. Is that all? Are there any other questions on this slide? We covered how writes happen, how reads happen. No, Ashish, that is not possible. Rajat says, do we read same block from multiple nodes and do a checksum to validate it? Yes, that is how files are read. Correct. Shrikant says HDFS, what information will be passed to HDFS client to get the metadata? In the next class we'll see, Shrikant, that we fire some commands on HDFS client to we just say we can say, like, if you want to see the contents, you can say a cat command, and that will display the results of your file. So, and internally all this happens. When you fire that command, it will go to the name node, get the locations, read the data, and bring it back to you. Yes, Dhananjay, only when name node sends heartbeat after write, name node stores the corresponding metadata in its RAM. It will have metadata about the file structure, that is which all blocks make the file, and this block map will keep coming to it every few seconds. It will get that information when it will receive heartbeat from data node. Okay. So I'll just quickly summarize what we did in today's session. I'll not run through. Can you show sample of edit log format? That is what Ashish is asking. Ashish, let's hold on to it for the next session. We'll see what edit logs and FS. For today, I just summarize what we have walked through. I'll not repeat. Okay, Shrikant, I'll try unmuting you. Meanwhile, you can also ask your question in the chat itself. I'll be summarizing. Till then, you can write your question here. I'll answer it. Okay, so we started with what is big data. Then we saw what is the challenge in processing the big data. Then we realized that storage is not a problem. Problem is with disk I/O, and we can cope up with it if we distribute our data to multiple machines. Then we saw how DFS can work as a solution to this challenge. We talked on DFS. We introduced Hadoop and talked about the 5 major important things in the Hadoop definition. Then we saw Hadoop architecture and understood the components, the 4 components: name node, data node, job tracker, and task tracker. We saw how a job is submitted to the Hadoop cluster and how it is processed. Then we also talked about rack awareness and fault tolerance in the system. Then we saw how reads happen and how writes happen. So we saw that writes are pipelined, that is they happen one after the other, and reads are parallel reads. We read from multiple data nodes at the same time. So this is what we did in today's session. And Shrikant, I still don't have the question from you. You were asking me something, right? Shrikant, am I audible to you? Am I audible to everyone? Okay, Sachi, please go ahead with your question. Sachi says, can cloud storage be a fit in Hadoop data nodes and cloud? Like you can have Amazon cloud to form your Hadoop cluster. That can be one good example that I can give. Mapper output is Dilip. Mapper output is a local storage. It happens on the data node itself where the mapper is run. It is not stored on HDFS because mapper is intermediate output for the reducer. Reducer's output is stored on HDFS. Yes, Suman, for the entire organization, we have just one name node and just one job tracker. Okay. Do we have any other questions? Okay. Ravi, I'm Nidhi. It seems you joined in late. I introduced myself. It's okay. It's okay. Yes, Dipankar, it will be, if you have installed Ubuntu, it will be sufficient for the next session. Also, we'll be giving you Cloud Era VMs. Our support teams will reach you on how to install and use it. So don't worry around that. You will get. Avinash, I've been working on Hadoop since 2.5 years. That is my experience in the area. Can we get the deck that we have run through? Yes, Rajat, you will get recordings and slides on your registered email IDs. Avinash, I told you I have a relevant experience of 2.5 years, and my total industry experience stands at 8 years. So, okay. Okay, so I think we are good with today's class, and what we'll okay, Dipankar, we'll talk about it offline. You can reach me on my ID. Okay, what is further reading material? Asked Rajat. Rajat, there is a lot of material online. To direct you at a particular book, I'll suggest you to read Tom White's definitive guide from. Uh, you can easily get it from Flipkart. Sachi, you can write for your VM support to our support team. They will get back to you and suggest. The book is definitive guide from Tom White. I'm sorry for that sound, guys. Guide written by Tom White. I'm writing it. I'll also ask the support team to send it to you, the book name. Okay, so I'll run you through a set of questions, and I need to check how many of you followed and how it went. So I'm sorry. These are the slides we did for the day. Okay. Can you see this question? What does HDFS stand for? Can everyone answer this question quickly? Yes, Tushar, you will get the presentation file. You will get it on your registered mail ID. You need to answer this question correctly, guys. I need to know if you've understood what HDFS is. Okay, so okay. I am still getting answers. Can you make it quick? Okay, so I have a few people did not answer it correctly. What is the correct answer? Altaf, Parthaban, Vamsi, they say it is option C, distributed file system. Yes, correct. It is distributed file system. Gone for Hadoop distributed data out DFS distributed file system, and then we added a Hadoop distributed file system. So that is the now we'll go to question. Says upon it in the class. I'll just tell you it is written in Java. Okay, we'll go for the next question. This is the last question that I'll get. What are the hard components? MapReduce and H. Okay, I have answer from Ranjit and Altaf. These two are first to answer. Okay, Tushar says not able to hear you. Tushar, you just have. Okay, the answer is C. It is MapReduce and HDFS. These are the two core components of Hadoop. This is what we saw in the slides when we were talking about core components of Hadoop, and then we went on to slides for data node and name node. Okay, I'll give you one question as well. Important, we discussed on it greatly. Hadoop is a framework that allows for the distributed processing of small data sets or large data sets. I want 100% answers on these. Okay, okay. Everyone says large data sets, option B. That is correct. Some people are not even voting. I have 62% votes. Okay. It seems some people have already left us. They are not answering the questions. Okay, I have 100% votes on large data sets. Okay, so we all pass with flying colors. We have 100% answers on that. Okay, guys. So that was all for this class from my side. I'm sorry, Sachi. It is very late for you. Yeah, I can understand it's late for you and you're feeling sleepy. I'm just closing up. That is all for today's session from my side. In case you have comments and feedback, please write back to us at Eduthika support. We'll get back to you on any problems or any issues that you have. And do keep reading on. Okay. Thank you, Ashish. Yes, Parthiban, I'll make sure that next time we don't have the voice issue. Thank you, Ravi. Thanks, Rajat. Thanks, Sachi. You can take your sleep now. Sorry for getting you late. Tushar says he missed something. Thank you, Rajat. Thank you, Gaurav. Thank you, Parthiban. Thank you, Sriram. Yes, Dilip, please, I'll ask my support team to get back to you for the Java course. You will get details on your mail. Don't worry about that. We'll send it across. So you have 2 weeks of time to cover it up. Yeah, thank you, Avinash. Thank you, Vinod. Thanks, Altaf. Okay, Gaurav and Dilip, we'll send Java course details to both of you. Don't worry on that. Yes, Ambarish, I understand you also need to get the Java course. We'll send it to you as well. So we have 3 people, Ambarish, Gaurav and Dilip, who need to do the Java course. Sriram as well. Okay. So all of you who want this Java course, we'll send it to you. Okay, it seems a lot of people want to do it. Parthiban, Rajat, Tushar, Dhananjay, we will send the details across, don't worry. Ashish and Rahul will send it to you as well. Okay, Dipankar, we'll send it to you too. Yeah, sure, sure. You can log out now. That's all from my side. In case you have questions, please reach back to us on our support mail ID. We'll get back to you. Yeah, thank you, Rahul. Bye, Rahul.
The organ